Yes, we can go live.
You're live.
Yeah. Good afternoon, everybody. So, I'm your host, Deepak, who is going to take care of the hall 2 and the session which is going to be there, track measurements and signal processing. And the paper IDs which are going to be present are 30, 37, 81, and 84. And we have our chairperson, Mr. Rajshri Gupta. I would like to introduce about him. Dr. Ayushi Gupta is currently professor with Electrical Engineering Section and Head Department of Applied Physics, University of Kolkata. So, Doctor, can we proceed with the first paper, paper ID 30?
Dr. Gupta, we can't hear you.
Okay, Doctor, proceed.
Greetings of the day, all dignitaries. Myself, Subhajit Bhumi. Today, I have present of my research paper, Determination of Fiducial Parameter of PPG Signal by Second Derivative Method.
Deepak, full screen.
In this paper, PPG signal acquisition and recorded PPG dataset from 10 pupils from different ages using derivatives and by identification of inflection points, the fiducial parameters are calculated from recorded PPG datasets. Then come to the introduction of this paper. In recent age, PPG is measuring tool of cardiovascular activity. In the PPG waveform, the first wave is forward traveling called systolic peak and second one is called diastolic peaks. In this diagram, the first this one is called systolic peak and the second one is called diastolic peak. Both are forward. The small downward deflection pulse is called dichotic notch, this one, just backward. In figure 2, peak-to-peak interval is defined as the distance between two consecutive systolic peaks. Please check everyone, this peak-to-peak interval means one systolic peak to another systolic peak distance. In figure number 3, that means this one, y is the height of the late systolic peak and x is the early systolic peak. The ratio of y to x is called augmentation index. Then come to the methodology. First step, PPG data acquisition. Output pin of PPG sensor module is connected to analog pin of Atmega 328 microcontroller board. The data acquisition program is implemented by embedded C language which runs on the Arduino IDE platform and upload the program on the Atmega 328 embedded microcontroller board to capture PPG dataset for human body with sampling frequency 250 Hz. Store the data points in .txt format using CoolTerm software to an array variable. In this diagram, this one is Arduino IDE module and this one is PPG acquisition board and this one is PPG sensor module. Then come to the next step, noise and baseline removal. Removal of high frequency noise from PPG signal using bandpass filter having cutoff frequency 2 Hz to 40 Hz. Limit the signal level using automatic gain control technique. Smooth and baseline wandering removal from the PPG signal using baseline grid. The filter sample data are loaded into array. In this diagram, the blue one is non-filter PPG dataset and the red one is filter PPG dataset. Then come to the next step, bit extraction. compute the global maxima and minima of all data points stored in PPG array, compute peak-to-peak value of PPG array, the local minima points indicating foot of PPG waveform points located in terms of index number and the corresponding amplitude are stored into two new arrays. The sample data points between two successive index value will form one complete bit of PPG waveform. The dataset of all bits are stored into two-dimension array and is stored in a data file. Then come to the next step. Determine of fiducial parameter. Read sample data value of PPG waveform arranged bitwise from the txt file. Compute first order derivative of all points stored from the array variable. Store the values into new array variable. In the diagram, this is a single bit PPG signal. In the diagram, this one is after the first order derivative PPG signal. Only one single bit. Compute second order derivative of all points stored from the array variable. Store the values into new array variable. This figure is second order derivative. This one is second order derivative. Find zero crossing index of array from first order array variable and store new array variable. Find zero crossing index of array from second order array variable and store new array variable. The second zero crossing point in first derivative PPG waveform correspond to systolic peak. The second negative zero crossing point in second derivative PPG waveform correspond to dichotic notch. The third positive zero crossing point in second derivative PPG waveform correspond to diastolic peak. Then come to the next step of the methodology. Determine PPG AI. The location of the inflection points A, B, C, and D on PPG waveform are determined from the second derivative of PPG signal. In the diagram, this one is A, this one is B, this one is C, and this one is D. The amplitude AB and AD are extracted from the second order derivative of the PPG signal at the location of the negative peaks B and D as indicated in figure number 9, particularly with the help of in this figure. PPG AI is ratio of the AD to AB. That means using this formula. Then come to the result of this paper. Find systolic peak amplitude and time, dichotic notch amplitude and time, diastolic peak amplitude and time from any subject tabulated in table number 1A. Find systolic phase, diastolic phase, PPG AI, and pulse interval from any subject tabulated in table number 1B. Determine mean value of systolic peak, dichotic notch, and diastolic peak from the subjects of different age groups tabulated in table number 2A. In this table, total 10 subjects are present from different ages. Then also determine mean value of systolic phase, diastolic phase, PPG AI, and pulse interval from 10 subjects of different age groups tabulated in table number 2B. Here also the same 10 subject from 10 different ages. Then lastly, I have come to the conclude of this paper or discussion of this paper. Systolic phase, diastolic phase, and PPG AI differences among the subjects. Determine magnitude of B by A index. It is useful function of the peripheral artery. Determine magnitude of C by A index. It is provide useful information of hypertension. Also, it is found B by A index. It is provide useful information of arterial stiffness. Lastly, I am very much thankful to Dr. Palash Kumar Kundu from Jadavpur University and Dr. Dharmodas Mondol from Technomen Salt Lake Engineering College. Then I am also very much thankful to Michael Faraday 2020 organization committee members. Thank you very much.
Hello.
Hello.
So
Hello.
we would,
Hello.
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 Am I audible, Shubhajit?
Yes, sir. Yes, sir. Yes, sir.
Can you show me your slides once again?
Sir, this is I will request the organization team. Okay, sir.
Okay, fine. Okay, then leave it. I will just ask you questions.
Okay, sir.
Okay. So what is I have few questions in fact.
Yes, sir.
You have detected the fiducial points, is it?
Yes, yes, sir.
So I found no accuracy results in your paper. Whenever we detect the peaks, so it is basically a classification problem. So basically sensitivity, predictivity, accuracy, these figures are shown. I could not find any accuracy figure. This is the first thing. Second, in your paper, I have checked the figure from table 1A to table 2B. There are no heading. In fact, what are the significances of these figures? Can you just tell me?
Which figure, sir?
Tables.
Table.
You have shown the
Okay,
tables,
okay.
different tables. You have
Okay,
shown.
sir. Table number 1A. Table number 1A. It is the significance of only because find the systolic peak, amplitude, systolic peak, amplitude and time, dichotic knock, amplitude and time, and diastolic peak, amplitude and time from any one subject, sir. And here I select the subject is 57 years for table 1A.
That is fine. That is fine. But whether your detection was accurate or not, there must be some error estimate.
Okay, sir. Okay, sir.
You have shown only whatever your algorithm has found.
Yes.
But whether
yes.
that finding is correct or not,
Okay, sir.
That has to be ascertained.
One compare is required, sir. Yes, sir. Yes, sir.
One standard is required, or manually you can compute.
Okay, sir. Okay,
Next question is that there has been many published works on PPG peak detection, especially from, if you go find the papers of Muhammad El-Gendi, which is a renowned researcher. He has done several work. So
Yes.
in future you try to compare your work and use a benchmark data. Okay, from Physionet you will be getting many types of benchmark data, and if you use those data with your system, compare with your system,
Okay, sir.
then you will be able to compare the performance of your algorithm with benchmark data.
Okay, sir.
Okay, and last one, I think there is a typos in your paper, because what I found that you have used a band pass filter.
Yes, sir.
Having cutoff frequency of
Yes,
2
sir.
to 40 hertz.
Yes, sir. 2 hertz to 40 hertz. Yes, sir.
2 hertz to 40 hertz. See, PPG frequency is around 1 hertz. So whenever you use any filter having cutoff frequency of 2 to 40 hertz, your PPG signal is gone. So I think it is a typo mistake. It will be 0.2 or something like this. I don't know. And 40 hertz is too high. It should be 0.2 to something 6 hertz or something like this. 40 hertz is too high, and many types of noise will come. Okay, so these are my feedbacks.
Okay, sir. Okay, thank you. Thank you, sir. Thank you, sir. Thank you.
Thank you, doctor, for your nice feedback. Now you would like to start with the paper ID 37.
I am Sandhanati Behra from Sikhya O Anusandhan University, going to deliver my talk on template matching based artifact detection from the brain signals. So in this topic, it is basically depend upon the template matching detection of artifact using template matching algorithm, and templates are generated using windowing method. Now for this work we have taken the data from Mendeley database. The sliding window method with 20% overlapping is done at the time of matching with template and detection. This method is time saving as because of statistical technique as compared to earlier technique used, and we got around 96.01% of detection accuracy and is observed from the proposed. Now coming to the introduction part, the recordings of the electrical current in the human brain skull is called EEG. For a healthy EEG signal, the amplitude is about 100 microvolt when measured on the skull and about 1 to 2 millivolt when measured on the surface of the brain, and the frequency range is within 0.01 Hz to 100 Hz. The EEG rhymes have 5 frequency bands such as delta, theta, alpha, beta and gamma. The delta band frequency range is from 0.5 to 4 Hz. Theta band frequency range is from 4 to 7 Hz. Alpha band frequency range is from 8 to 13 Hz. Beta band frequency range is from 14 to 30 Hz and gamma from 30 to 100 Hz. The artifact may occur due to external sources or due to external sources. The artifact is the unwanted signal that is mixed with the EEG signal, and due to which we cannot obtain the clinical information properly from the EEG signal. The external sources of artifact like lead movement or power line interface, so like this. But the internal artifacts, this is otherwise known as physiological artifact, they occurred due to muscle activity, heart rhythms and movement of eyes. Now some in this literature review sections, some of the algorithms or some of the methods used for detection of artifact from the EEG signal, so such as independent component analysis, and artifacts are obtained with the help of second order blind identification, and also some statistical technique used with the independent component analysis to detect the artifact. The method adjust, which is a method of for identifying artifacted independent component, and Infomax also used for artifact detection. The canonical correlation analysis also used for artifact detection. Some of the machine learning technique also used for artifact detection and also for artifact removal. Now for this proposed work, we have used the method template matching algorithm for detection of artifact. This is the block diagram of proposed method, and in this block the description about each block is given in the following slides. First we go for pre-processing, then windowing, then windowed EEG, then template matching, then EEG template, then detected artifact. Now, before this, EEG template database should be created. Now how the EEG template database is created is discussed later. Now for the pre-processing, that means all the EEG signals are undergoes through pre-processing method. Now, pre-processing done by normalization method. The normalization of the EEG signal is done by the following relation. So, now we can get the normalized EEG signal by this equation, that is EEG minus EEG mean divided by EEG max minus EEG mean. So here EEG mean is the minimum amplitude of EEG signal and EEG max is the maximum amplitude of EEG signal. Now coming to the formation of template. Now for formation of template we have taken Gaussian window. The Gaussian window equation is given as Gn equal to e to the power minus n square by 2 sigma square, and where a range of n is in between minus L minus 1 by 2 to plus L minus 1 by 2, where L is the size of window taken and sigma square is the variance of the Gaussian window. The amplitude of this Gaussian window is fixed to the amplitude of a clean EEG signal. After that, for formation of template, the window is slided over the EEG signal. The portion of EEG signal greater than the amplitude of window is set to as artifactual window. Then autocorrelation of that artifactual window is taken as a template. So similarly, the window is slided over entire length of the signal. So number of artifactual window is created and that are stored in the database. So this is how we the template database are created. Now in this figure, in figure number 2, the clean EEG signal is given and artifactual EEG signal is given. The clean EEG signal, the amplitude range is in between minus 30 to 30 microvolt, and for the artifactual EEG signal the amplitude is in between minus 50 to 100. So it is the amplitude may be more than 100. Now here some of the artifactual window is displayed or shown with indicated by marked by the ellipse, and in figure 3 so the some clean EEG window and artifactual window of sample size 256 is displayed here. Now for template matching, with the help of template matching, the artifactual window is identified and the position of artifact can be known. Now the EEG signal window is obtained by sliding window technique. Thus window size is taken as 256 to maintain the time and frequency resolution. Now autocorrelation of that particular window is matched with the templates. The similarity measure between two templates is obtained by the correlation coefficient. Now correlation coefficient is given by this equation where x1 and x2 are two templates and m is the size of template. Now for the result, the clean EEG signal is displayed here, and this is the artifactual EEG signal, and in third window the clean EEG signal samples of 256 size, and in fourth the artifactual EEG signal of sample size 256. Now if you take the autocorrelation of two clean EEG signal, it will look like this, and here we can see if we consider the autocorrelation of two contaminated EEG signal, it will look like this. Now for this is the table where the detection coefficient of different windows in EEG signal is shown, and here we have taken only 11 windows and the detection coefficient corresponding to those windows are marked, and here we can see the detection coefficient for the artifactual window is more than 90%, and for detection coefficient for clean EEG window is less. Now for the comparison, we have taken in the in the paper, they have taken the reference number 23. They have taken the data from the BCI competition 2003, and they have applied SVM method. They got 90% of accuracy. Now in reference number 24, they have also taken SVM and got 95% accuracy, and in 25 they have taken the template matching with the DPW algorithm. They got 96.10 accuracy, and the proposed method we have applied the template matching algorithm, and we got 96.1 accuracy. For conclusion, the quantification of artifacts from EEG is proven successfully, and for this template generation, we have taken around 23 samples are generated, and 11 windows are formed for each sample and tested. Though many methods are being applied, the extension of this work will include the different way of template generation and matching with independent correlation coefficient to enhance the accuracy. And these are some of my references. Thank you.
Now
Thank
we
you for
have
the
2 minutes.
presentation.
Now we have 2 minutes of question and answer.
Yeah. My first question is that was your template taken from the noisy dataset or clean dataset?
We have taken the templates from noisy dataset. Actually, only the noisy dataset templates are considered.
So whenever you are detecting the noisy portions, again it is a typical detection problem. So have you tested the false detection rate or F1 score or PPB values?
F1 score I have
Yeah,
not.
these are typical classification. Yeah, but false detection rate or sensitivity.
I have only calculated the accuracy and the sensitivity.
What accuracy should be calculated based on true positive, false negative, all these things. Have you calculated those things?
From the table we have calculated the true positive and false positive, and from that we got the accuracy.
Okay, and in your table 2, I have found that the references are too old, around 15 years. So have you compared with any recent work, maybe between 2018 to 2020? Because I found that most of your references are 2014, 2004, 2005, these years.
Actually, reference recent terms I have taken, but I have not compared those things. But they got less accuracy than I got in this proposed method.
Actually, concluding based on only 11 windows is not sufficient, I think. Okay, you have to take at least 1 hour of duration of data. Otherwise, it is very difficult to compare, because the methods, the quarks with which you have compared, I'm sure they have used much longer length of data, because robustness is a problem. Because in few windows, your method may be very good, but in other windows, your method may not work as satisfactory in other earlier windows. So only a thresholding based, you are calculating the correlation. In fact, it is basically a correlation match. So only a simple thresholding, that too, determining the threshold is also a difficult. So I think you can modify this method to incorporate other things like computational intelligence or some other thing. Okay, thank you.
Thank you, doctor. Now we'll proceed with the paper ID 81.
Hi, greetings to everybody. Hope you all are well in this pandemic. Myself, Dr. Shomojit Goswami. I am the Managing Consultant and IT Architect in IBM India Private Limited. Today, I am going to talk about our paper called Design and Implementation of a Prepaid Energy Meter using IBM IoT. Before starting, I would like to thank to my co-authors, Professor Dr. Argho Sarkar and Professor Dr. Samarjit Sengupta. The subtopics I am going to cover are abstract of the paper, the problem statements, and their proposed solution, design and implementation of that solution, business benefits can be achieved, and the conclusion. First of all, I would like to start with the abstract of the paper. This paper deals with the design and implementation of an IoT-based energy meter for effective utilization in smart cities. The main advantage of the proposed smart metering system is that the consumers get the itemized hourly electric usage on daily basis to take precautions for saving consumption, primarily in peak hours. They also get the automatic notification regarding date of renewal, pre-planned power shutdown details, special offers, etc. The another advantage in is power connection and disconnection happen automatically from the remote server as per tariff plan and user payment. Node-RED supported public cloud-based IBM Watson IoT platform is utilized to implement the proposed scheme. This slide talks about the problem statements. In many occasions, it has been seen that consumers are dissatisfied due to their high energy billing, not receiving bill before payment due date, no notification for over usage and date of renewal. At the same time, the energy providers are also dependent on huge manpower for collecting monthly meter reading and power supply connection disconnection of the defaulters. In present days, there are many reasons for lack of automated energy conservation. Those are consumers do not have information on hourly usage, no idea on peak hours, flat billing rate without considering peak and non-peak hours. This slide demonstrates on the proposed solution. As per the solution, a smart meter should be installed at consumers' smart homes, which consists of current and voltage sensors for capturing readings continuously. Captured sensor data are encrypted and fed to the computer using a Raspberry Pi, which is registered in IBM Watson IoT platform. The entire logic is maintained in Node-RED software, which calculates hourly energy bill for every customer and maintains consumers' selected tariff with date of renewal. Hence, it acts upon live sensor data and historical data from database. It takes the responsibility to send daily SMS and email notifications of consumers' hourly usage. To design and implement the solution, a set of hardware components are required. 20 ampere 100 millivolt per amp ACS 712 current sensor, VCC 25 volt voltage sensor, 64-bit 1.5 GHz Raspberry Pi computer, optionally 100 MHz Ethernet cable are recommended. Sensor captured voltage and current are used to measure active power, reactive power, apparent power, and ultimately the energy. This slide depicts the formula used to measure the power components and energy. As mentioned previously, IBM Cloud's Watson IoT platform is leveraged to deploy and execute the simulated solution flow. To utilize the platform, first a user credential has to be created and Raspberry Pi should be registered as an IoT device. Once registered, it can interact with Node-RED using its security token. This slide demonstrates the Node-RED simulated flow. Node-RED, which is built on Node.js, is a browser-based programming tool primarily used for IoT device connectivity. There are a number of explicit nodes used for our solution, which are mentioned in this table. A sample SMS and email notifications with itemized hourly electric usage of a particular consumer are presented in this slide. Both energy providers and consumers may achieve several benefits by acquiring the proposed solution. Energy providers can reduce manpower by automatic power supply connection disconnection for the defaulters and by automatic capturing of energy consumption reading. They can charge the electricity bills on hourly basis, that is, high charges for prime hours. Ultimately, this solution improvises the customer satisfaction. On the other hand, consumers will be having a clear idea about their hourly usages, renewal date, pre-planned power shutdown, special offers, etc. by receiving personalized email and SMS notifications. Human errors in the billing system can be discarded by applying this approach. This is the slide for drawing concluding remarks. It is worth to mention that this paper is all about a prepaid energy meter implemented for the benefit of both power suppliers and its consumers. IBM IoT and Node-RED software are utilized to implement the solution. The authors are grateful to IBM for providing access to its cloud environment. Thank you all.
Okay, thank you for the presentation.
You can have the
I have
questions
few
now.
comments. Okay,
Yes, sir.
actually, in the slide, what I found in the abstract slide and in the benefit slides, many general things have been discussed. This can be done, this could be done, but whether these were actually implemented in the system, because the portions which were emphasized, IM, IoT, IBM, Watson, and Node-RED, here there is no research contribution. Your contribution should be in the signal processing part. Okay. So may I know what is what sensors have been used and what was the resolution of the ADC that was used in acquisition of the data? Because I could not find any ADC. You cannot connect the sensor directly to the Raspberry Pi because Raspberry Pi is not having any internal ADC.
Yes, sir. So what we have done is we just did one simulation in Node-RED software, and in
No,
that
no, I am not asking about that. I am asking how did you feed the data from the voltage sensor and the current sensor to the Raspberry Pi?
so the data is encrypted. After encrypting the data, it is fed to
No, no,
the
you are not getting my point. You are collecting voltage samples and current samples. Okay.
yes,
You have used two sensors. From that, those two sensors, the voltage samples and current samples will go to the Raspberry Pi. Then you have multiplied, then you have calculated the phase
yeah,
angle and calculated and integrated over time. But how you are feeding the data from the voltage sensor and the current sensor to the Raspberry Pi? That is my question.
yeah. There should be one analog to digital converter, but
Why you
that
are
will
telling should be, you have not used?
that's what I'm saying. Like it's a kind of simulation. So the simulation
You
part
have
is
not
done by
used
using.
you have not used Raspberry Pi.
So the data from the Raspberry Pi is used in the Node-RED.
That is the later part. See, in the node rate, you don't have any research contribution. My point is that how did you feed the data in the Raspberry Pi? You have shown the voltage and current sensors, all these things. And also that since you have done a measurement problem, there should be an error analysis. How much accurate was your measurement of energy and power? And since you are using Raspberry Pi, you have ample scope of calculating the active and reactive power on peak demand. Have you calculated these things?
Yes, active power, reactive power, power factor, all those things are calculated.
Calculated. You have not shown in your slides. That is why I am asking.
Actually, in slide number 7, it's there. So the formula and all,
No,
that
no,
is there in slide
I
number 7.
I could not find the result. In fact, actually, and
Okay.
the problem is since you are using Wi-Fi, I think you are using the Wi-Fi for uploading to the this using this IBM Watson cloud. Is it?
No, Wi-Fi is not required in this
Then
case.
how you are how you are using the Watson IBM Watson cloud in with your Raspberry Pi? How you are connecting?
Yeah, so to connect it, there are two options. One is through Ethernet connection and another one is through internet.
Hmm.
We can register this Raspberry Pi into IBM Watson.
No, no. What you have done, you tell me. What you have done actually.
Yeah, that's what
There
I'm
are many
saying.
options. I know.
Yeah, that's what I'm saying. So what we have done is we have registered this Raspberry Pi into IBM Watson. After registering it, it can feed the data to the IBM Watson
In
directly.
real time, how your Raspberry Pi will feed the data to IBM Watson cloud? That is my question. See, you will be installing this Raspberry Pi based meter in the consumer installations. Okay.
Yes,
So
yes.
from here, it will collect the voltage and current samples, then calculate the phase lag and integrate. So
Yeah.
energy is calculated. Then you have to connect to the IBM Watson cloud. How that connection will be done from the Raspberry Pi?
So the couple of things are required for this Raspberry Pi
Mhm.
ID. Then I mean the device ID, device.
Yeah, that is
I mean
fine.
all
But
the details
what,
are required to
what will be the
register it.
physical connection mode?
Okay. Physical connection mode is Ethernet connection.
Ethernet. So that means Ethernet means you will be having either wireless Wi-Fi or LAN. That will be required. So that means the houses which will having this facility must have a Wi-Fi or a physical LAN port. Is it?
Yeah, physical LAN port. Yeah.
Okay, okay. Fine. So these are, I think, some limitations of this work. You could use easily a GSM based communication. If you can install a just GSM connectivity in your with your Raspberry Pi, then you
Yeah.
can easily connect using the data services of the mobile services. That is the thing.
Okay.
Okay, thank you.
Thank you.
Thank you, doctor. Now we have paper ID 84.
Myself, Pramit Brotochandra. I am from Jadavpur University. I am basically PhD student under Professor Shubir Kumar Sarkar from Jadavpur University. My research domain is medical image processing and pattern recognition in soft computing, and uh, I am doing my research work regarding this work, medical domain. I am presenting my work on that is medical image-based approach for classification of several stages for retinopathy disease using machine learning methodology. My paper ID is 84. The abstract of my topic is basically the diabetic retinopathy is a type of disease that will gradually enhancing throughout the world. It is one of the major concern for diabetic patients also. It is because of the possibility of color blindness for the patients. It is one of the challenges for society to reducing this color blindness. The work is basically performed for the OD classification of several stages in retinopathy like mild, moderate, severe, etc. So early detection and providing the treatment is very important and crucial for reducing the probability of color blindness. The main objective efficiently segment the blood vessels and optical disc area to detect and classify the abnormalities present in the eye area. Basically, here to the detection is identification is of optical nerve blood vessel abnormalities are present in retinal images or not. That is the main objectives. Next, introduction part. In introduction part, the retinopathy is one of the disease that is major concern for diabetic patients are responsible for color blindness. And also these images are slightly deviated for fundus images, sub-components like microneums, hemorrhages, etc., cotton spots, etc., present or not. Due to presence of this feature, the retinal image area might occurs the possibility of loss of vision for the particular patient. The main purpose of the work to detect the several abnormalities present in the retinal images or not, and in the future of our world, that is the probably almost more than 20 million of people can be affected this diabetic retinopathy upcoming 10 to 15 years. Here several types of diabetic retinopathy standardized data sets are used for work that is openly available. We have used for training and testing, training for 80% and testing for 20%, and direct DB0, direct DB1, drive and steer, etc. data sets are there for working in this domain. Several objectives are there for detecting retinopathy, diabetic eye disease, and damaged retina, detected damaged retina, and also that is the more sophisticated version, that is glaucoma and damaged optical nerve. That is the important things. And increasing blood pressure level in the eye, that detecting the blood pressure level is very difficult task. That is our future work, and detecting the damaged optical nerves. These are the proposed algorithms, which consist of several stages. First is the reading the original input image, this color image, and then pre-process it and changing the image to grayscale image and resizing operation is performed. And then reduction of unwanted pixel or noise is very important, because unwanted information may hamper the proper result. So several filtering approach for reducing the noise, several filtering approaches are used, like Gaussian, median filtering, etc., for reducing the noise. And next, some enhancement of the data is required for removing the desired part and enhancing the brightness or contrast of the image. Mainly, brightness or contrast can be enhanced using some histogram-based intensity analysis approach that is used here for changing the brightness or contrast, and then some segmentation approach like morphological approach like morphological opening, closing, dilation, erosion, etc. are used, and also some threshold-based segmentation are applied for separating the area of abnormalities, exodus and abnormalities present in the area from the background image. And this is a foreground image that, according to the some threshold value, it will set the threshold, and then beyond the threshold, some values will be printed, and within the threshold, some will be given. And some other parameters, statistical parameter like mean, entropy, MAE, mean absolute error, etc. are calculated. This is for error parameters, and also some image quality parameter like PSNR, MSC, SSIM, etc. are measured for affected retinal images. And then some accuracy parameters, classification accuracy parameters are measured. That is using some SVM classification parameter at several kernel, different kernel level. In some linear kernel, RBF kernel, polynomial kernel level, the accuracy values are calculated. And after that, final segmented optical detected optical that is final optical disc detected images are extracted from the retinal images where sees the abnormalities are present or not. Here some of the statistical parameters in results, our statistical parameters are calculated: SSIM, MSC, PSNR. PSNR is peak signal to noise ratio. As per the first and last images, PSNR is quite higher and MSC is quite lower. That will give the image quality parameters are good. And if you see the SSIM, also SSIM for the last two or three cases, it is almost near about 0.9. That is the ranges of the value is 0 to 1. That will be get the value is 0.9 ranges, it is good results. And also the optical disc ratio we have calculated for the first images, it will be 4 points image, it is the severe cases, and other is the, that is 1 point, it is the mild, and these are the moderate cases, or 2 point, that is these are almost moderate cases of the optical disc ratio parameter. And here the statistical parameters of noisy images are calculated. For MAC, for the noisy images are quite higher, and MAE is quite, main absolute error is quite lower, and UIQI is the universal image quality index, that is also for the first 3 images it will give 0.8, that is good range. Next come the comparison of several algorithms. If we see the comparison of several algorithms, our approach SVM kernel with intensity based threshold based approach provides the abnormal detection is more than 85% rather than other cases for detecting the several abnormalities efficiently, and for the normal images it is almost more than 85%. That is good for the other cases rather than other cases. If you see the comparison of accuracy SVM kernel, uh, the kernel level, the linear kernel, the red bar, it shows the quite good results, and also the polynomial kernel, the green bar, it is also good for the images. For the image 1 and image 5, it will give the linear accuracy quite higher. And next, the comparison of several accuracy for using several approaches, SVM adaptive with morphological based segmentation. If we compare that, the blue color bar is our method is quite more than 88% accuracy level for abnormal and 85% that is for the normal cases of detection. If you see the execution time for execution, it will show the our method, that is last bar, blue bar, will show the less execution time, means it is timely efficient. The time complexity is quite lower for the our algorithm than other. And also other parameters like image quality, MAE, MAC, these are quite lower for the particular method. For the image 1 and image 6 quite lower than the other. And UIQI as usual, it is quite higher. And if you see these algorithms like yellow bar, which is our method, it will provide for the 3 cases sensitivity, precision, recall. If we see this method, sensitivity, precision, recall, and if we see that our method will provide comparatively better than the sensitivity value is quite higher, more than 86, and precision is also 82, and also recall is more than 80% than other methods. These are the comparative results of several existing algorithms. The second and third method, it is using neural network based approach efficiently detect the exodus and area of blood vessel, and also second method, that is threshold with blood vessels and microanions, it is more than 90% of accuracy. And this algorithm also good results. This is using clash based segmentation is 93.41. Our method also provide more than 85% of the accuracy, and normal detection and abnormality is detected at 88% with SVM kernel based approach for detecting the optical disc and microanion efficiently. This is the illustration of a particular work. One illustration is the original image, that is the enhanced image, it is the morphological based segmentation image, visual based segmentation image, also it is the final optical disc detected, or what are the changes in the optical disc, that is the mild cases of the algorithm that is detected here. And also is the conclusion part. The conclusion part, mainly the work is basically provide more than 85% accuracy, and also it is done with the method for classifying the patient's diabetic retinopathy and exodus efficiently from the fundus image. The proposed approach will provide the better accuracy than the other comparing method, and also it is efficiently identify the abnormalities earlier and takes faster decision to provide the next stages of the treatment of the patient carefully to do the patients. And this is the references of some papers, IEEE transaction and some other important papers of conferences we have studied and used for our research study. Thank you for giving me the opportunity for presenting paper in MFIS 2020. Thank you at all.
Okay, am I audible?
Yes, doctor, you're audible. No,
Actually, whatever method, there are several methods of image processing methods. for detecting diabetic retinopathy. It is a very long pursued research. So what is new in this work? Am I audible?
Yes, sir. Yes, sir.
Yeah. My
Yes,
question is, what is the new research content in this paper? Whatever
Hello?
you have discussed, yeah.
Hello,
Whatever
may
you
I
have
audible?
discussed,
Hello?
yes, yes, you are audible.
Okay. Sir, please.
Should I repeat?
Yes, yes, sir.
Actually, my question is that whatever you have done, this type of works have been published many times. What is new in this work, in this research? I mean, in your work?
Basically, the work is based on the retinopathy classification, and retinopathy several cases are there. We have detected these cases using non-linear based algorithm, that is SVM based SVM kernel based algorithm, for classifying the several cases according to the optical disc ratio, where the values are belonging within that are belonging within that cases, and on the basis of that we are classifying the particular cases that have severe, that are mild, moderate, several classification on
Yes,
the
but
basis of the optical disc ratio, and also those statistical parameter like classification accuracy, sensitivity. These are used to basically to use to classify whether the patient is mild or moderate or severely classified in diabetic patients.
fine. But whatever you have told right now, several works are there. Several works are there. At least 50 to 60 papers are there, which have used SVM, nonlinear kernel, and this type of thresholding. Actually, in your paper, I found that the methodology section is very small compared to a 6-page paper. So what thresholding rule you have used? What is the principle of segmentation you
Yes,
have used? These are not detailed.
thresholdings are basically thresholding. Here we have changes the threshold value, and according to the threshold, changing the
Now,
threshold.
how did you choose the threshold? How did you choose? Since it is an
Normally two
automatic
types of
method.
threshold can be there. That is local threshold, global threshold. We have used here.
But it is not described in your paper. In your paper, when people will read, they will not understand what type of thresholding you are telling to me. But after
Oh,
the conference,
I have
nobody will
used
have the.
basically global threshold value. We have changed at it accordingly, that foreground to background pixel, the threshold will changes accordingly. We have detected the microaniums and other abnormalities, and optical disc region is present here. How it is
this
changes, that will
this
be
should have been written in your paper. In your paper, you have not you have used 3 inch or 4 inch of just column length for
basically,
describing
sir,
your method.
conference paper, it will be very hard to discuss all the things.
Yeah, but
That
things
is
in
the main problem.
this is a prestigious conference and it will be uploaded in digital library. My second question is that, did you use any feature minimization? Did you calculate any feature significance?
Feature extraction are done basically.
But
Feature
whether those
minimization I
features,
have not done. Feature extraction I have done.
do you know what is feature minimization?
Feature minimization, no.
Whether all your features are contributing towards the classification accuracy, that is basically the feature minimization or feature optimization. So significance of each feature is required. Maybe whatever features you have used, hand-picked features, you have just calculated the entropy. There are several types of entropy are there. You have not mentioned also. So whether all these features are contributing positively towards the classification accuracy, that is required. In your subsequent studies, you can have a study on whatever features you are using, whether all are contributing positively, and those features which are not contributing positively, these are called noise features. So what I
Yes.
suggest is that you use any feature minimization method. There are
Means,
several
are
feature
you saying say
minimization methods.
noise reduction? Any noise
No, no,
reduction
no.
method?
Feature minimization. There are many methods: filter methods, wrapper methods, recursive feature elimination, binary PSO. There are several methods which will give you an idea whether all the features, suppose you have taken 5 to 7 features, whether all these features are significant for this classification, that you can assess. This is very important. Otherwise, these
Is it
features,
related to any optimization process?
no. This will enhance the accuracy. You have used 86% accuracy. So if you maybe some of the features are acting as noisy features. So they are basically destroying your performance, classification performance. Okay. So this is very important, and this will add the value to this paper also. Feature minimization. You just remember these names.
Thank you, sir.
Filter method, wrapper method, recursive feature elimination, then binary PSO. There are several methods.
Okay.
Okay. Thank
Okay,
you for
thank
the
you,
good
sir.
work. Okay. Best wishes.
Thank you.
Thank you, doctor, for the
Sir,
session.
thank you.
Thank you.
Your feedback for all the papers, sir. Thank you.
Thank you.
Thank you. Can I leave now?
Yes, doctor.
Yes,
Sure.
sir.
Thank
Yes, sir.
very
Yes.
good.
Thank you, sir.
So now we'll start our second session.
Yes. Start.
So
Before
we are waiting for our chairperson, Dr. Asim
Hmm.
Datta. He is yet not joined.
before start the session, please join the chairperson. Okay.
Yes,
After
yes, he
that,
is
start.
not joined yet. We are waiting for him. We
This
have
is the
called him. We are
necessity.
just waiting for him to join
Yes.
the session.
This is the necessity.
So we can start the session. Dr. Asim Datta is there. So the next session is on power and energy, and the paper IDs which are going to be present are 72, 73, 74, 78, 88, 90, and 95. Before that, I would like to introduce our chairperson, Dr. Asim Datta. Good evening, Doctor. Dr. Asim Datta received the BE.
The next হবে তো next session এটা কমপ্লিট হয়ে গিয়ে এখন হচ্ছে তুমি এখন যুক্ত করতে হচ্ছে একদম পুরো হচ্ছে কাজ সমাজি স্যার এসে যা বসে এখন কে হবে তত এখন সিভি বি রুবি কজন আছে নাকি একটা দুটো তিনটে ছটা সাত
Are you getting me now? Myself Oshim Datta. Hello. Okay. Sir, ঠিক আছে, sir.
So I'll go ahead with the introduction of Dr. Asim Datta. Dr. Asim Datta received the BE and MTech degrees in electrical engineering from Tripura University, Agartala, India, and the University of Calcutta, India, in 1999 and 2001, respectively, and the PhD degree in engineering from the Indian Institute of Engineering Science and Technology, Shibpur, India, in 2015. From 2012 to 2016, he was an assistant professor with the Electrical Engineering Department, National Institute of Technology, Meghalaya, Shillong, India. Since 2016, he has been an associate professor with the Electrical Engineering Department, Mizoram University as well, India, and is currently the head of the department. His research interests includes energy engineering, grid-connected PV system, energy conversions, embedded systems. He has published more than 40 research articles in peer-reviewed journals, several of which are in high-quality journals like IEEE Transactions on Industrial Informatics, IET Renewable Power Generations, etc. He has been a principal investigator of 3 R&D projects funded by DST and CPRI and IT. Currently, he is associated as principal investigator to an Indian-Mexico collaborative project. So doctor, with your permission, can we start the sessions with the first ID, paper ID 72?
Yes, yes, yes.
Okay, doctor.
Dr. Datta, don't forget to mark. All will go. Will be considered for journals special issue. Please mark as per your own judgment.
All judgment. Okay, okay. By grading, I will mark. No problem. Yeah, yes, yes, yes. Present.
So we are starting the session.
Everyone, today I am going to present the paper titled Complex Network Theory-Based Analysis of Cascading Failure of Electrical Power Transmission Network Against Intentional Attacks and Outages, authored by Dipanjan Bose, Chandan Kumar Chando and Abhijit Chakraborty, presented by Dipanjan Bose. Complex network theory is employed in topological modeling of power grid network to assess the vulnerability of the power transmission network, followed by an intentional attack or outage. The parameters of the topological structure of complex network has been utilized to analyze the criticality of the power transmission network subjected to a potential threat or outage. Attacks can also lead to cascading failure, causing substantial damage in power transmission sector as well as economical aspects of power sector. The concept of preferential load redistribution is being considered to examine the possibility of cascading failure in the grid network. That has been investigated and tested on topological model of IEEE 57 bus system. In most of the countries, power grid is a typical complex network that is distributed throughout a vast geographical region. The grid operation possesses threat of failure due to localized fault or intentional attack, which causes the power to flow through adjacent lines or neighboring lines. In many cases, neighboring lines can be capable to withstand the extra load, but in some cases, the neighboring lines get overloaded and tripped, and this phenomena may spread over other lines and resulted cascading failure of the system. Complex network theory represents a power network as an undirected graph. Degree of a network can be defined as the number of nodes in adjacent to that lines and represented by equation number 1, and weighted degree of a graph can be represented by equation 2. Practically, it is always preferable to transmit power through the shortest path to minimize the transmission loss as well as cost. Therefore, average shortest path length is considered as an essential characteristic of complex power theory. Average path length of a network is defined as the average of all the smallest distances between nodes. Therefore, this can be represented in equation 3, and the weighted path length thus represented by equation number 4. The clustering coefficient gives the measure of the average closeness between nodes in graph, or we can say that it measures the degree to which the nodes in a network tend to cluster together, and this can be represented by equation 5 and 6. Cascading failure is a common incident in power transmission grids when one of the elements fails completely or partially and shifts its load to nearby elements in the system. These nearby elements are then pushed beyond their capacity, so they become overloaded and again shifts their load onto other elements, which subsequently causes islanding of the power system. Power transmission capability of a line is the injection of power from generation bus G to load bus D, and it is expressed in equation 7. electrical betweenness qualifies the contribution of a component to power transmission in a whole power grid. In this respect, the elements, namely buses and lines of the power grid, can be ranked accordingly to their criticality. This can be represented in equation number 8. Depending upon the PTDM matrix, electrical betweenness can be classified in two categories, positive betweenness and negative betweenness. The maximum among them two categories of the betweenness can be chosen. Then, by introducing a tolerance factor epsilon, which represents the ability of a line to handle increased betweenness in order to retain the line operation within specified constraints. This modified value of the electrical betweenness represents in equation 12. A line may be termed as overloaded, making it vulnerable to failure, when modified electrical betweenness must be greater than power transmission capability of the line. After an outage, the power flow of the tripped line gets redistributed using the concept of preferential probability, which can be represented in equation number 13. Now, for the collapsed overloaded line, the extra electrical betweenness transferred to the neighboring lines, and that is represented by equation 14. And this process of collapsing the neighboring lines or nodes continues till any surviving line condition occurs. Targeted attacks can be classified into two categories. One is attack or outage of bus, and another is attack or outage of line. The network state can be assessed using static and dynamic method. In dynamic method, recalculation and execution of the algorithm is done to periodically identify the highest betweenness value, whereas in static method, algorithm run once and result highlights the assessment of cascading failure of the system. In this paper, the modeling has been done on IEEE 57 bus test system, and the topological model of the system shown in figure 1, and the associated clustering coefficient values versus the number of nodes has been plotted in figure 2. Figure 3 shows the flowchart of the cascading failure of a power network. At first, the system should be initialized. Then evaluate the generation dispatch process using generation load balancing Newton-Raphson optimal power flow. Then the value of electrical betweenness has been calculated. After that, for assessing the cascading failure, attack scenarios have been simulated by removing highest electrical betweenness line or node. Load redistribution among neighboring line has been occurred. Next, the overloading condition checked whether the value of electrical betweenness of line exceeds the power transmission capability or not. If yes, then go back to the process where evaluation of generation dispatch process was occurred using NROPF. If not, then again check for the isolated nodes. If no isolated nodes occurs in the system, then the system may survive. But if there is any isolated nodes, the system undergoes cascading failure and islanding condition occurred. In this process, the transmission line with highest electrical betweenness of IEEE 57 bus system has been identified as line number 70, and it is removed in the simulation process. This induced load redistribution among adjacent lines like 14, 15, 16, 18 and 26. Now from the table it is observed that line number 26 has highest electrical betweenness, but the power transmission capability of the line is more than that. Therefore, this line 26 is survived during overloading condition. Next highest betweenness value of the line is 15, and it exceeds the limit of power transmission capability. Therefore, the line gets tripped. The simulation reveals that the overloaded lines followed by redistribution of loads among adjacent lines with highest degree betweenness leads to islanding condition. The mapping diagram of this process shown in figure 5. From the table, it is observed that line number 21 has survived tripping, which leads to termination of the process, but the system is islanded. It has been found that load flow converges if possible till the line 23 is tripped. In the next step, the bus with highest electrical betweenness is tripped. This induced load redistribution among adjacent lines. The simulation reveals that continuation of the iterative process for removal of an overloaded line followed by redistribution of loads and subsequent identification and tripping of lines with highest degree betweenness leads to cascading failure. The mapping diagram shown in figure 7. During islanded operation, the system parts divided into 2 or more sections, and each section may tend to have overvoltage or undervoltage problem depending upon the amount of generation available in each section. This paper has proposed a topological cascading failure model for complex power grids, identifying critical loads using electrical betweenness and redistribution of load associated with preferential probability of load attachment has been utilized here. It has been observed that tripping of this terminating line would result in islanding of the power grid. It is hence concluded that the proposed method is an efficient technique for analysis and assessment of cascading failure following outage of overloaded lines. Thank you.
So thank you, Dipanjan.
Yes, sir.
Hello, I am Dr. Oshim Datta.
Yes, sir.
Yeah. Okay, thank you for your presentation. First, I am asking whether anybody, those are connected, having any question. So anyone is free to ask any question and for any clarification.
Hello, Mr. Bose.
Yes, sir.
Hello.
Yes,
yeah,
sir.
I have a question.
Yes.
Can you specifically mention your own contribution, and can you mention that whether it can be extended for any application in a smart grid area?
Yes, sir. Here we have been calculated the cascading failure method to implementing the grid operation, the disruption in grid operation. Now, in the event the cyber security and cyber attacks scenarios, this system can be extended that some node and such a line can be tripped by the attackers, and due to that the system may get failed. By using the complex network theory as a model, we can extend this thing to assess the bit.
Is it existing model? Is it existing model, or your contribution is coming here?
Yes, sir. It is not an existing model. We have been tested this model in the IEEE 57 bus and wanted to extend this model up to IEEE 180 bus system and some real data test system.
Specifically mention your contribution. That means in algorithm or whatever.
The algorithm has been developed on the basis of highest electrical betweenness line, and depending upon this, if the line betweenness of the line is more, the system is more prominent to our.
Have you made any comparison with
No,
other?
no. I have not made the comparison yet.
But it can be done, yeah. Is it?
Yes, sir. It can be done.
Thank you. Is there other question?
Can I ask one question? Hello.
Yes, sir. Yes, sir.
Yeah. How do you measure the betweenness centrality or something else of the line?
Using the complex network theory model, the topological model has been assessed, the IEEE 57 bus system, and I have been more calculated this using the MATLAB simulation tool.
MATLAB simulation tool you have to do it.
Yes, sir.
Okay. You have graded these lines using the centrality facilities, betweenness facilities.
Highest betweenness lines has been ranked highest electrical betweenness.
Okay. So you have analyzed accordingly. So this may be your contribution probably, and
yes,
I do not know whether anything has been done. Anything has been done from your attacking point of view.
No, it is not done yet. I am just intentionally attack. I have checked the highest betweenness value is 70. So I am intentionally attack that node. Due to that, I have been checking the results.
Okay, then thank you.
Okay, sir.
Any more question?
Thank you, doctor.
Anyone to ask question? I think. Okay, Dipanjan.
Thank you, sir.
Yeah, just I am asking one.
Yes,
It is a power network, right? An
yes.
intentional attack means what type attack you are implying?
So this attack may be done by cyber attack or cyber terrorism. If the data of the system goes to any terrorist, and he will be attacking is the highest electrical betweenness bus, which will create the system to be more vulnerable for the existing one.
Data mean suppose from the server system, control system, data can hack
Power,
like that,
exactly, sir. And
or
from that system, the
or
transmission lines.
like power stolen. This thing also can be there in
No, it is not considered yet. The
okay,
power
okay,
storing concept
like
has
internet
been.
sort of thing you are
Yes,
implying,
sir.
right?
Yes,
Okay, then this clustering coefficient value one graph you shown, right?
yes, yes.
So these values, some are high and some are low. Huh?
Hmm.
Actually, what does implies these coefficient values?
The importance of the node in a system. What is the how much the node is important to a system? It is being classified using that. How much the nodes, the
Okay.
lines will be clustered together in a node.
Uh, okay. And suppose yeah, here is a 57 bus system, right? You
Yes,
consider?
yes, yes, sir.
This server system, whatever telling, where you are considering this server system, there is number of in every node there is individual server system or centrally any server system. What you are assuming?
Nah, central server system, from the central server system point of view, it has been.
Central server system, right?
Yes,
Server system means monitoring all the buses.
yes. All the buses and all are in data flows.
And okay, so this monitoring also like our internet monitoring, how communication.
Same procedure will follow there in the system. In this paper that has not been included, or in using the cyber attack, we have to incorporate that thing also. The communication portion is must be included in this paper for the later on or future work.
Okay, 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 like intention. Okay, thank
Thank
you
you.
for your all clarification and your
Thank you,
good
sir.
presentation. I think no other question. So thank you,
Thank
Deepanjan.
you, sir.
Thank you. Next.
Thank you all. So we'll proceed with our next paper ID, which is paper ID 73.
Hello everyone, this is Dr. Navamita Banerjee Roy, Associate Professor in HOD, Department of Electrical Engineering, Narula Institute of Technology. I am going to present the paper on application of signal processing and artificial neural network in modeling of a scheme of distance relaying system for protection of overhead transmission lines. This paper has been authored by two of us. First is myself, and the other author is my student Madhulina Dash. Basically, she was going to present the paper because this is a part of her MTech project work. But due to her illness, she is unable to do the presentation. So I am presenting on her behalf. We know that the technological development has resulted in increase in dimension of power system, and hence detection of faults in such large systems is a challenging task. Protection of power system is very important to ensure reliable and continuous power supply to the consumer as per their demand. For the protection of transmission line, the most important part is to detect different types of transmission line faults and clear the fault as soon as possible. The purpose of protection system is to interrupt the faulty section from the healthy one because the fault currents may damage the electrical equipment. Distance relaying is a major kind of protection system as well as it works as a very good backup protection. So it is of very good protection system for the transmission line and the entire power system network. The objective of this paper is to demonstrate the application and advantage of the technique of signal processing in modeling of a transmission line relaying scheme. This is the block diagram or single line diagram of the power system network, which has been used for the study of this paper, in which all the different kinds of faults have been simulated. Normally 10 types of faults have been simulated here: short circuit faults, shunt faults, that is line to ground with phase A to ground, phase B to ground, phase C to ground. Then double line short circuit faults, AB, BC, CA. Double line to ground faults, AB, GB, CG. Then triple line or symmetrical three-phase short circuit faults. All the faults have been simulated in steps of 10 km from the bus B1. The fault resistance or impedance has been kept fixed at 0 ohm. The other specifications of the system are being given over here, with the sampling time of being 50 microseconds, and the fault inception time has been taken to be fault inception angle has been taken to be 0 degree. Now, actually, initially, this modeling of the relay was done in such a way so that the during no fault condition, the line impedance of each phase was calculated. And during any fault, it was observed that the line impedance of the affected phase falls below the value than the normal condition, and this is actually the case. But in the simulated relaying system, the line impedance of each phase during a fault condition was compared with that during normal condition. We will go to the block diagram of the relaying system in the later slides, but this is a brief introduction of the earlier work that was done. The output was either 1 or 0 in the simulated relaying system. So in this way, the faulty phase was detected. So this is an illustration of the three-phase voltage waveforms during different kinds of faults occurring at 100 km from B1. First one is the ABC three-phase short circuit fault, and the second one is the double line to ground fault. These two another three-phase waveforms for double line short circuit fault and single line to ground fault. So this is the block diagram of digital impedance relay that I was talking about, that initially only the raw voltage signals were taken, and the impedance of each phase was calculated, and this comparator compared the impedance of the phase of those values with the normal values, or rather the impedance values under normal condition. So the output is 1 if there is a fault, and it is 0 if there is no fault. So this simulated system worked successfully, but could not detect correctly all the fault conditions. Hence, it was decided that the relay would be tested using features extracted from processed signals. So before I go into the details of the analysis, let me give a brief introduction of the different kinds of soft computational techniques that are applicable for investigation and analysis of power system transients, that is signal processing tools and applications. The tools of signal processing is mainly available are Fourier transform, short-term Fourier transform, wavelet transform, S transform. So why is the transformation needed? The transformation of a raw signal is needed because a raw signal is mainly a time domain representation of the signal. So a transformation gives the frequency domain component of the signal as well, because we need to know what types of frequencies are present in the signal. So Classification of signals, we know, I would go very rapidly because these things are very familiar to all of us, that there are two kinds of signals, stationary signal and non-stationary signal. Stationary means in which the frequencies remain constant over the entire length of time, whereas the non-stationary signal is one in which the frequencies vary with respect to time. So Fourier transform, we know it's a very powerful and very popular tool to get the frequency domain of a frequency component of a signal, but it has some of the drawbacks. So the drawbacks is that if it is a non-stationary signal, that is in which the frequency components vary with respect to time. I am not going into the details of the Fourier transform because these are familiar to all of us. So see here, two types of a signal has been taken here. Obviously it is stationary. This is the waveform of the signal, and here is the FFT, or the signal, the frequency, the spectrum obtained after applying the FFT, fast Fourier transform. So what are the drawbacks? That because the Fourier transform tells only whether the frequency component exists or not, but not the time at which the frequency component exists. That is, the time component is totally lost. So FT of a stationary signal is seen with respect to a stationary signal. How does it look like? Fourier transform. Whereas the FT of the non-stationary signal, you see, it's almost the same. Very little with some glitches over here. Other than that, it is almost same. So it's very difficult to, there's no way of finding out that at what point of time which components of frequency exist. So after this, actually this drawback was overcome with short-term Fourier transform, in which the signal is considered to be stationary segment wise. So the non-stationary signal was once again considered, and actually short-term Fourier transform, it gives a time, frequency, amplitude representation of the signal. So short-term Fourier transform is good for the analysis of non-stationary signals, but there is a problem because the window width of that is taken to analyze the signal, that is fixed in width. So if it is a wide window, there will be good frequency resolution, poor time resolution, and whereas if it's a narrow window, it will be vice versa. So to overcome this problem, wavelet transform came into the picture, in which the width of the window, it can be varied. So it was termed as multi-resolution analysis. So the width can be varied depending on the frequency. Good time resolution with poor frequency at high frequencies. So actually, I'm going fast because this is also very popular, because wavelet transform is also very popular in the analysis of transient signals. So width of the window changes as the transform is computed for every single spectral component. So wavelet transform is very efficient in the analysis of non-stationary signals. So I would skip these slides because there are many kinds of wavelets that are available for the analysis. Okay. And in this paper, continuous wavelet transform has been applied. Because continuous wavelet transform, though it gives the output matrix is very large, but the thing is that it gives a very detailed information of the signal, and the wavelet coefficients that are obtained, though they are very huge in number, but it helps in a very detailed analysis of a signal. So we can get very important information if we rigorously investigate the coefficient matrix of the continuous wavelet transform. So these are the steps of the computation of continuous wavelet transform. It has been programmed using MATLAB toolbox. So these are some of the examples how the wavelet functions occur. Analyze a non-stationary signal, how the window is shifted for different values. So let us come back to the work that we have done here. Here CWT, continuous wavelet transform, has been implemented on the voltage signal of each phase in which a simulate for wavelet has been used as the wavelet function. The maximum number of scales have been chosen to be 128. Well, it can be increased if you want, but it was seen that even if after increasing the maximum number of scales, after a certain limit, the values of the coefficients do not change. So there's no point of changing the number of scales to a very high level because at some point of time it will saturate. So we have investigated the signal with different values of scales. We have taken the number 64, we have taken 128, after that 256. So we have seen as the value is saturating, the magnitude of the coefficients is saturating. So we have restricted ourselves to the value of 128 so that the storage, the occupation of the memory of the computer is not very high. So this is the time frequency representation of the voltage signal of phase A in case of single line to ground fault, that is AG fault occurring. This is just an illustration. So what has been done over here, that in the earlier one, the impedance values of the raw signal were fed to the computer as the input features. But here what we have done, the maximum value of the wavelet coefficients of each phase is calculated, and it is termed as Cn max. The same is calculated for the different types of fault conditions and coined as Cf max. So Cn max is compared with Cf max of each phase, and the faulty phase is detected. So this is an example of how the magnitude of Cf max happens for different fault location. In case of AG fault, it is seen that the values do not vary much with the change in fault location. Yes, for the faulty phase, the values are quite lesser. The values are quite less compared to the healthy ones. It is seen from the picture. So this is another diagram of the plot of the magnitude of CF max for different fault conditions in case of AB fault occurring at 100 km from B1. So now what actually the fault classification was done, the results that have been, we have successfully classified all the kinds of faults with 100% accuracy. But as it is seen that all the values of CF max, whatever was obtained, they do not change much with respect to fault location. So we had to shift to another signal processing. Once again we are coming back to fast Fourier transform here, because what we found is that the FFT, from the FFT, this is the FFT of the voltage signal of the faulty phase A. Now this is just an illustration. Now from this we calculated THD, total harmonic distortion. Now it was found that the total harmonic distortion, the magnitudes of total harmonic distortion for different fault locations were varying, and this is an plot of the different values of THD for different fault location in case of AB fault. So now the THD can be used as input features. If they are trained, then we can get the fault location. So obviously artificial neural network has been applied, in which the back propagation algorithm has been chosen to obtain the fault location, as that in which the THD values have been used as the input parameters. So the backpropagation neural network, the architecture of it has been given over here, that what is the size of the input vector and what is the size of the target vector. Actually 20 features have been used for training. The Levenberg-Margot algorithm, which works very efficiently in function approximation problems. I have many papers in which the fault locations have been obtained successfully. So this has worked successfully in many of the earlier research works, in my works as well as in other works of power system fault analysis. The number of neurons, the transfer functions, all the specifications are given over here, number of epochs, and the goal of accuracy. And this is an illustration of the training process, how that happened during the backpropagation neural algorithm. And this is a plot of the actual fault location with respect to fault location obtained from BPNN. So it is seen that the values were very close to each other. And here is a table of the, in which the maximum error has been calculated for different types of faults. So the absolute value of the the errors percentage error was calculated for different fault locations, and the maximum error that was obtained in each case has been shown over here. So from this we can see that the maximum error that is obtained is around 5.63%, which is an acceptable value. So in the conclusions, we can say that a simple approach has been presented over here for the development of a distance relaying scheme. Only the voltage data of a single terminal have been considered for fault identification and as well as determination of its location. Both fast Fourier transform and continuous wavelet transform work very fast, and they do not depend on the number of samples of the signal. Irrespective of sampling frequency, they work quite fast, and also they are immune to noise, which is in a practical situation most of the signals contain a lot of noise. So both FFT and CWT are quite fast and they are immune to noise. All the simulated faults have been classified with 100% accuracy, and the maximum error of determination of fault location has been achieved to be 5.63%. So the suggested method is acceptable and quite reliable, and it can be extended. Study can be further extended for different values of fault resistances, fault inception angles, as well as multi-terminal system. So in the future scope of work, I would like to extend this work by simulating, or rather by implementing it on a hardware model. That is the objective of the extension of the paper, so that the whatever has been simulated, that can be tested on a practical circuit. So with this I end my presentation. These are the few references that have been referred for the work in this paper. So thank you.
Now we can proceed with the questions.
Yeah. Dr. Banerjee, I have one point to raise, that you have not maintained the template. You have not maintained the template, or you have not followed the template. And IET digital library is watching everything. So I don't know why you have done this. And secondly, you have mentioned that in your work for future extension, that it may be extended in a real application on real modeling. Can you share your views how this can be experimentally implemented?
First of all, am I audible? Hello?
Yeah.
First of all, my sincere apologies here, because I had to do the presentation in the 11th hour when I found my scholar was hospitalized. So my sincere apologies here for not following the template. But yes, if I get the scope, I can resubmit if there is any option. So and the second thing is that regarding the hardware simulation, actually the block diagram that I have presented in the paper, I thought of, implemented it by using logical or hardware circuit, especially by using a microcontroller Arduino based model, if it can be done. But actually, let me see if I can proceed with some of my next scholars, if it is possible. Also, I have some practical data, of course, with me. If that is not possible, then I can test the same with those practical data as well.
Okay, that's technical issues will be taken by session chair. But I request you, please submit your presentations very shortly, within tomorrow, in proper template. Otherwise, digital library will not consider.
Okay, sir. Thank you.
Please do it. Yeah.
Proper template and number of slides, 15 slides, within 15 slides.
Okay, sir.
Yeah, madam, thank you for your presentation. Okay, so you explore this digital signal processing aspect, right? For the distance relay applications. Okay, before my question, I am asking any question. Those are connected here. If anyone want any question or any clarification.
Actually, I can I make one question? It's very
sure.
Simple question. Initially, in the model, what I could see, the rating of the generator is around 200 something MVA and 200 kV, where the connected load is 10 kilowatt and like that. So is it practically feasible, or it is only taken for simulation?
Hello, sir. It's only for simulation purpose. Grid source. I mean, the
But
source
the
was
data,
represented in the grid source.
data which are being used are not at all practical, na? Say 200 megawatt or 200 MVA generator with 10 kilowatt load. So where from you will be, you have derived a lot of data and say basic principles of transmission line protection schemes and many transforms. So the basic concept from which you have started seems to be a bit, is it not?
But sir, actually,
In
thing is that
simulation,
I will recheck the rate. I recheck the load data in that case.
no, not like that.
Okay.
Just the block diagram that you have shown. The block diagram
Yes,
that
sir.
you have shown, I think you have used the blocks from your MATLAB.
MATLAB. Yes, sir. MATLAB. Yes,
So
sir. MATLAB.
MATLAB is giving whatever you will want, they will give it to you. But you have to make a network which is practically feasible. A 200 kV generator is also not possible. 200 MVA generator is possible. And with that, one 10 kilowatt load, connected load may not be logical. So please check the things before resubmitting, as Dr. Chattopadhyay was telling.
Okay,
Okay.
okay, sir. Okay, sir.
I have one question. Okay. Can I ask? Hello? Hello?
Please
Am I
ask.
audible?
Please ask. No problem.
Yeah, yeah. Regarding this distance protection, okay. So what is the coverage distance have you considered? And the other question is, have you considered any partial fault? That is also an issue. What should be the tolerance? Okay.
Sir, the line distance that have been transmission line distance that have been taken over here is 200 kilometer. And regarding the partial fault, I don't get it. I mean, I have simulated the short circuit faults that I have mentioned 10 times the faults, shunt
But the
faults.
biggest challenge is the occurrence of the partial fault. That is the main challenge of distance protection.
Partial fault, sir, can you please explain with respect to, can you please explain what kind
Do
of
you know
partial
the
fault?
conditions of partial fault? How partial fault occurs? Do you have any idea?
No, sir.
Partial
Can you
fault
please explain partial fault with respect to what? It's, I mean, I have mentioned the data of the short circuit fault.
Yeah, the ground short circuit.
The fault
means the short
resistance,
circuit-
fault resistance was taken here 0. It can, I have not, that has not been varied.
That's why in reality, the partial fault, that means the fault resistance can sometimes may not be 0.
Yes, sir. Yes, sir. That I have mentioned, sir. The fault resistance here has been considered to be 0, but definitely it can be, the study can be extended after the variation of the resistances as well.
Okay.
Yes, sir. For this paper, it has been taken to be 0.
Okay. Okay.
Yeah. So, any question?
I have
Anybody
one.
else?
I have
Yeah.
one question. Can I ask?
Please ask. Please ask.
Yeah. So in the presentation you mentioned that you used the TANSIC function, if I'm not wrong. So what made you use this function specifically, or did you do any hyperparameter tuning to get these parameters?
No, sir. No, sir. I have used the plain MATLAB toolbox, and I have purely made the application of this TANSIC version on the basis of the previous results that I have received in my earlier research work. What I have found is that the TANSIC function has earlier in my research work has given very acceptable results. So on the basis of my experience, I have used this function. And here also I have get reasonable values.
Okay. Any more question? Okay, madam, I think a lot of question already asked. Only one clarification only. In simulation model, whether you given any tangent, etc., you checked whether it can distinguish between transient and fault. Are you getting me?
No, sir, not exactly. Can you please
Yeah, I am
elaborate?
saying, yeah. Actually, protective relay main challenge is distinguishing transient and fault, right? Distinguishing our some as usual transient and main fault, differentiating, this is the main issue, main challenge. So whether you in your simulation model you considered any giving some transient also, whether a scheme can distinguish between fault and this transient.
Oh, okay, sir. If I have got you correctly, I think you were mentioning about any transient conditions like switching conditions.
Yeah, correct.
Okay, sir. No, sir. In this paper, only the short circuit faults have been considered. No, other than that, no other switching conditions or surges, any other surges have not been considered here.
Okay, means transient where relay should not trip, this thing not
No, sir.
considered, right?
That has not been the part of the study.
Acha, see, okay, part of research means you see your artificial neural network you are using, right? You have to train properly this artificial network so that this one can distinguish, right? So how you are thinking you can train this
Sir,
neural
in
network?
that case, the parameters, I mean, the simulations had to be further extended to other switching conditions. Well, in power quality, also those kind of conditions can be simulated, different types of surges that can be simulated. So that conditions had been then incorporated, and the training input features had to be re-extended.
Okay, means it required to done, na?
Yes, sir.
Still now you're not done. Okay.
No.
Okay, thank you, madam, for your
Thank you, sir.
presentation. Okay, thank you.
Now we'll go ahead with our next presentation. That is paper ID 78.
Uh, 74 is there.
Nowadays.
74 is done now.
74.
So this one is 74.
Yeah, doctor, we have completed the paper ID 72 and 73. This is 74.
Okay, please present.
Yeah.
Microgrid is very popular and harmonic analysis is one of the important topic. Hello everyone, I am Sumangal Bhomik. Today I am going to present the paper on harmonic analysis in solar penetrated on-off grid microgrid using ETAP. In this presentation, we basically discuss about this following topic. In microgrid, the various distributed energy resources like solar, etc. are penetrated into the grid utilizing power electronics converters. This type of interface, together with the non-linear load, result in the harmonic power flow in connected network. So our aim is to analyze the effect of integration of medium range solar photovoltaic system into the low voltage distribution grid and how to mitigate the harmonic problem in microgrid to the optimum way. This is our proposed model of medium range solar photovoltaic system. This is the photovoltaic system which are connected with PV solar bus with help of inverter and step up transformer. This bus voltage is 415 volt. This is our grid bus of 11 kV which are connected with load bus with help of step down transformer. Here LCB1 and LCB are low circuit breaker which are play important role to our analysis. Because this switching of this circuit breaker, we divided our analysis in three modes. One is grid mode, another is SPV mode, another is hybrid mode. In grid mode, LCB is closed and LCB1 is open. This one is open, this one is closed. And SPV mode, LCB is open and LCB1 is closed. And in case of hybrid mode, both LCB are closed and grid and photovoltaic system are working together. All observation in this paper are based on ETAP simulation. In case of load flow study, here we use adaptive Newton-Raphson method to get better and accurate result. Here we see the load flow study result. Here we observe the voltage variation of PV solar bus and load bus were maintained to close to the normal value by adjusting the taps of the transformers. Before starting the harmonic analysis, we have to know about the component which are responsible for generate harmonics. Here, the inverter and non-linear load are generate harmonic. This is the harmonic spectrum of 6-pulse inverter, where the THDI value is 25.22%. This is the harmonic waveform of 6-pulse inverter. In our study, we use two types of inverter. One is 6-pulse inverter and another is 12-pulse inverter. This is the harmonic spectrum of 12-pulse inverter, where the percentage THDI value is 10.32%. This is the waveform, the harmonic waveform of 12-pulse inverter. Here we consider furnace load as a load. This is the harmonic spectrum of furnace load, where the percentage THDI is 24.12%. This is the harmonic waveform of furnace load. This table shows the comparative study between Rockwell 6-pulse inverter and Rockwell 12-pulse inverter with, for harmonic analysis at SPV mode. Here, at full load, the percentage THDV is 29.87%, and at half load that is 22.68%, and lean load 6.81%.
Just
This
1 minute. 1 minute.
29.87%
Hello.
is this the value is very high with respect to the standard value. So to reduce this percentage THDV, we have to use the filter bank. So using stage 1 filter bank, the percentage THDV is reduced to 6.2%. Still, it is not in the range. So we have to use another mode where we use stage 1 and stage 2 filter in combined mode. Using this mode, we get the percentage THDV is 2.9%. This is the preferable value as per IEEE 519. Same study we done for Rockwell 12-pulse inverter. For full load, no inverter, no filter case, we get the 16.32% at full load. At half load is 12.96%, and at lean load 4.52%. And to decrease this value, we use stage 1 filter here and get the value 6.9119. And another again we use the stage 1 and stage 2 combined mode, and we get the value 2.61% for full load. The additional advantage of this stage 1 filter is it improves the load power factor to 0.7 to 0.95. This table shows for Rockwell 6 pulse inverter case and the harmonic analysis of hybrid mode, and here this shows the grid mode. At hybrid mode, the full load CHDV is 2.58% and at grid mode it is 1.18%. In this both mode, the percentage CHDV is very low. For this reason, we don't need any type of filter. Here, same analysis we done for the Rockwell 12 pulse inverter. For hybrid mode, the full load percentage THDV is 2.05% and in grid mode it is 1.1%. Here we see this value is very low. So for this reason, we don't need any additional filter to reduce it. But in economically, a 12 pulse inverter is expensive with respect to 6 pulse inverter. This is the result of harmonic analysis. This is the harmonic waveform of PV load bus for 6 pulse inverter at normal condition, that is no filter condition. And after using two-stage filter, we get this type of waveform. This type of waveform in harmonic waveform for PV load bus for 6 pulse inverters. Here, this is the harmonic waveform of PV load bus for 12 pulse inverter at normal condition, and after using two-stage filter, we get this type of waveform. Conclusion: in this observation, it is observed that 6 pulse inverter together with multi-stage harmonic filter bank ensure improvement of power factor from 70% to 98%, as well as reduction of percentage THDV from 29.87% to 2.61%. That is well within the limit stipulated by IEEE 519. Thank you.
We'll start the questions round.
Yeah.
Yeah.
Have you yeah. Have you done this work in isolated manner or in with grid connection?
Sir, here we use 3 modes. One is isolated, another is grid connected, another is 2 modes also. We consider 2 modes. One is isolated mode, another is hybrid mode, that is grid connected.
In simulation or in real?
Simulation, sir. ETAP simulation.
ETAP.
ETAP, yes, sir.
Another question is that you have shown some waveforms. Do you think that those shapes of waveforms you have shown will remain same for different load condition or with respect to time?
I think, sir, it is ETAP simulation, so I think it is correct.
So if time varies, if you in ETAF, can you consider variable time or?
No, sir. Isolated. So I don't think it is considered a variable time.
Will the shape will remain same with respect to time?
Yes, sir. Remains same.
Yeah. Okay. And what are the scopes for future extension of your work?
Sir, actually, our main study, if we design this type of system that without filter bank. So if now we can compare with us Rockwell or other 24 pulse inverter, and we can accompany we can add the wind and other mode of the DG in our system and study this analysis and the harmonic analysis.
Okay.
Yeah. Now, any more question?
Yes, sir. I would like to
Yeah.
ask a question, sir.
Yeah.
Uh, Actually, I have seen your presentation. I would like to know that in recent days, it is noticeable that the THD value of the voltage is important, but THD value of the load current is far more important. And you have used the furnace load. Then why didn't you calculate the THD value of the load current? You haven't compared it.
Sorry, I can't get you.
Am I audible?
Yeah, you are.
In the recent days research, it is noticeable that the THD value of the voltage is important, but THD value of the load current is also important. But you haven't mentioned the THD value of the load current as you have used a furnace load in the inverter.
Yes, but actually, in THD value of voltage depends on impedance, and in starting case, when I consider the Rockwell 6 pulse and 12 pulse inverter, here we consider the THDI value, current the THD value of current.
THD value of current you have used?
Yes, we consider it. We can't after the using the filter we can't see the value here, but at starting condition the load
at steady state condition you have used the voltage THD, but I am asking for the when you have already connected the load, then you could also have measured the load THD, load current THD value.
Yeah, that is not considered here, but primarily we consider THDI for load furnace load and 6 pulse and 12 pulse inverter. We consider THDI value. But
okay, nice work.
So, any more question? Anyone want to ask question?
So, Doctor, can we proceed with the next presentation?
Please start the next paper.
Thank you.
Good afternoon, everybody. Now I am going to present my paper entitled Subharmonics Data-Driven Adaptive Line to Ground Fault Detection in Solar Fed Microgrids. Myself, Tapas Kumar Das, and my co-authors are Dr. Surajit Chattopadhyay and Professor Aurobindo Das sir. Now, I want to show the overall idea of this project of work abstract. This paper basically deals with FFT and DWT based analysis of statistical parameters.
You make a full slide. You make full slide.
Solar fed microgrids. Here, the solar fed arrays have been used as energy resources to the microgrid system. The voltage source converter based inverters have been
full
used
screen
conversion purpose.
Can you make full screen?
From DC to AC, and its output signal have been considered for analysis. Subharmonics content, THD and DC component present in the current signals have been measured both at normal and LG fault conditions. The approximate and details coefficient have been measured and analyzed by their kurtosis and skewness values at different decomposition levels. Significant changes have been observed in subharmonics content, skewness, and kurtosis at certain decomposition level during LG fault conditions with respect to normal conditions. Introduction. Here, this with the increase of power demand and with diversity of non-conventional energy resources through microgrid has increased to a great extent along with the along with the conventional grid system. Low voltage power resources are being connected to a high voltage grid system as well as the load distribution system. For reliable operation of the microgrid system, quality assurance and fault detection are two significant challenges faced by power engineers nowadays, and lots of research work is going on to study and cope with these challenges. But a very few work have been observed for unsymmetrical ground fault assessment using subharmonics content present in the microgrid system and derivative level-based statistical parameter like kurtosis, skewness, etc. This has motivated us to take an attempt to assess a single line ground fault at high voltage bus near load end and from low voltage inverter terminals. The fault diagnosis has been made by study of subharmonics, TSD and DC components, skewness and kurtosis values of DWT based approximate and details coefficient of low voltage inverter output currents. A case study has been carried out for validation of the whole work, and this has motivated author to take an attempt to assess the single line to ground fault at high voltage bus near load and from low voltage inverter terminals. The fault diagnosis has been made by study of subharmonics content, also based on TSD and DC component, skewness and kurtosis values of DW based approximate and details coefficient of low voltage inverter output terminals. This is the plan layout or model of the 400 kilowatt microgrid system, which has been considered for this paper here in the extreme left. By the different blocks, we are showing the PV arrays which are connected here to generate the electrical energy, and after generating the electrical energy, these are being fed to the input side of the three-phase inverter, and from the output side of the inverter, it is supplied through bus 1, transformer 1, bus 2, bus 3, bus 4, and the output side of the inverter is also connected to the conventional grid as well as the different load systems. FFT-based assessment. A computer algorithm that calculates the discrete Fourier transformation much faster than other algorithms is the first Fourier transformation. The Fourier analysis transforms a signal or wave to a representation in the frequency domain from its original domain and vice versa. A typical 400 kilowatt DSC based microgrid model was contemplated in this study, and FFT instruments were used to evaluate current signals. Output currents of the inverter have been monitored carefully to study the line faults of the phase A, phase B, and phase C under normal and found conditions. Various computer simulations have been carried out in order to find out amplitude of the subharmonics components for every 10 Hz intervals, magnitude of DC component and TSD values. Finally, the using captured data graphical representation have been prepared to study their characteristics, similarities and responses. The magnitude of subharmonics, TSD and DC component versus normal and fault condition of a 400 kilowatt microwave system has been shown by the different subharmonics based bar chart as well as the radar chart of subharmonics component. The TSD and DC component nature of 400 kilowatt microgrid system under normal as well as fault conditions that we can see here by these 4 different figures. DWT-based fault assessment. Discrete wavelet decomposition has been performed on the non-stationary carrier signals of phase A at output terminals of inverter both normal condition and at LG fault conditions. The characteristics curve of skewness and kurtosis values of both approximate and detailed coefficient have been considered to assess various line faults. Wavelet decomposition has been carried out up to the DWT level 9. The skewness values of approximate coefficient versus DWT levels have been shown in figure below. From figures, the skewness and approximate coefficient in phase A for both normal and fault conditions remain low and constant up to DWT level 6 that has been shown in the figure. The skewness values are different at DWT level 7, 8 and 9 at DWT level 9. The SA values for different fault conditions considerably different from each other. So these are the different nature under SA versus DWT levels, HD versus DWT levels, K versus DWT levels, and KD versus DWT levels. That is skewness and kurtosis, approximate as well as detailed coefficient nature we have shown by using these 4 diagrams. Parametric selection. Based on the result presented in the previous section, few levels can be chosen and utilized for fault assessment where distinct differences have been observed between normal and fault at different phases. For skewness of approximate coefficient 9th level and for skewness of different coefficient at level 1 have been chosen. Also for kurtosis of approximate coefficient 9th level and kurtosis of different coefficient at level 1 have been also chosen. Also for kurtosis of approximate coefficient 9th level and kurtosis of detailed coefficient at level 1 have been chosen. By subharmonics based observation, normal and fault zone may be isolated as shown in figure below. So here the faulty zone and methodology for detection of fault detection selection have been shown by this diagram. Every 10 Hz frequency interval we have shown the 4 different figures. Here the faulty zone or relay operating zone is showing by this arrow above this dotted line, and below the normal zone or relay non-operating zone are showing here under the LG, AG, LG, BG and LG, CG for different 3 phases, A, B and C phases, LG fault conditions as well as normal conditions. Now this faulty zone as well as the normal zone has been shown by using the different nature under the different normal as well as fault condition for every 10 Hz frequency interval. We have also shown this radar chart for showing the different normal zone as well as the faulty zone or the relay operating zone. In the figure, the inner part of the radar corresponding to normal condition and outer part of the radar has been considered as the operating zone for protection unit. The methodology used for fault detection here, based on the above, the fault detection is prepared as follows. First of all, we have monitored the inverter output currents, then measured the subharmonic components, performed wavelet decomposition, and calculate SA at 9th level and SD at level 1, then perform the wavelet decomposition and calculate the Ka at 9th level and Kd at level 1. Finally, compare with set values and detect the fault. Now, case study and validation. In case study portion, the two different cases have been considered for LL and LG based on the data collected from real application. The deviation from the normal as obtained from the various captured data has been compared by bar chart as shown in figure below. In all cases, the KD and derivative level 1 shows the maximum deviation. At that means KD at level 1 is the highest for both cases, and we have also shown the other K, SA, SD, A10, A10, A30, and A40, TSD, and DC components at a glance for two different cases, case 1 and case 2, by this figure. Now outcome of this whole work is we can express as therefore in a single parameter is to be chosen for fault diagnosis, then KD at DWT level will be the best. KD at DWT level will be the best. KD at DWT level 1 will be the best. According to the methodology may be modified as follows further. That is, monitor the inverter output currents, measure the subharmonic components, measure the KD at DWT level 1, compare with the set values and detect the fault. Now, the conclusion of this whole work is the significant changes have been observed in subharmonic skewness and kurtosis at certain decomposition levels at fault condition with respect to normal conditions. On the other hand, the skewness and kurtosis of approximate and detailed coefficient increases at certain DWT levels during the line to ground faults and become maximum at the fault located in the phase under consideration. The parameter selection SA at DWT level 9 and SD at DWT level 1 and K at DWT level 9 and KD at DWT level 1 have been chosen. The protection scheme has been developed with respect to these parameters. Case studies have been carried out on actual scheme which gives similar types of changes in parameter values at those levels, validating the proposal which may be used for effective analysis of faults. Finally, the FFT and DWT based analysis of statistical parameter for line fault diagnosis in solar microgrid with single parameters has been concluded that the KD at DWT level 1 will be the best parameter for this purpose. This is the conclusion of this whole work. Now, I want to give my thanks to the whole organizing committee for arranging such a wonderful event. Thank you. Thank you.
Okay, thank you for presenting. So, any question from anyone?
Sir, I have some questions.
Yeah,
I have few questions. So, first of all, here the fault has been detected, but the the time which is needed for detection of the fault is not mentioned. So, in practical scenario, the fault should be detected as early as possible. So that's why I'm asking that what is the fault detection time of the fault. Okay, this is the first question. And second question is that DWT is considered here, discrete wavelet transform. So what is the mother wavelet? Which mother wavelet has been taken for DWT analysis? And this is the second question. And third question is that it has been observed that kurtosis for detailed coefficient at level 1, it is maximum. So what are the interpretations of kurtosis of detail level? So these are the three questions. Okay. Am I audible? Am I audible?
Hello.
Sir, am I audible?
Yes, yes, yes.
Okay.
Hello.
Hello.
Am I audible?
Yes, yes.
You all are audible.
Hello.
Yes, yes. Just you answer. Huh? No problem.
Sir, actually, first of all, we have taken we have uh, considered a model of 400 kilowatt microgrid system. It's basically a solar based system, and we have uh, uh, captured different data from the output side of the three-phase inverters, and based on those data, we have first done the FFT based analysis, and then
No. It's okay, fine. But I want to know what is the fault detection time. Okay. So here the fault has been detected. So in practical purpose, the fault should be detected as early as possible. Okay. So that's
yeah.
why I am asking you, what is the fault detection time here?
Sir,
And
here we have used MATLAB simulations and
okay, fine. It's okay. Grid connected solar system you have considered for that. But I want to know what is the fault detection time. You should mention here the detection time, and
okay.
based on that, you have to develop your protection scheme. Okay. So that is why I am asking that what is the fault detection time.
Okay, sir.
So
Actually, sir, here the simulation work have been carried out based on the standard time frame under MATLAB simulation environment.
No, it's fine. But I want to know after the occurrence of fault, how much time is needed to detect the fault. Okay. So detection time should be as early as possible. So this should be considered. And
Okay.
second thing is that you have considered DWT, discrete wavelet transform.
Yeah.
Fine, but I mean which DB, I mean DB4 or DB10. What is the mother wavelet? I mean which mother wavelet has been taken for
Sir,
analysis?
that we have already mentioned in our paper, sir. DB4. That we have.
DB4, right? But why DB4? Why not DB10? In case of diabetes group, so many mother wavelets are there. You can see Mexican hat. You can see Morlet. So why diabetes group is taken and specifically DB4 is taken? Why? Have you tried other mother wavelets?
No, sir. Hello.
So this comparison should be needed. Okay. So
Okay, sir.
this is the second question. And third question is that skewness and kurtosis has been considered. Though all these things are the statistical parameters, but here it is used to detection of the false statistical signal processing, we can say. But here we can observe that that the kurtosis for detailed coefficient is maximum. So what are the interpretations for that?
Sir, for that we have carried out a comparison table we have prepared, and there we have established and we made an algorithm to validate our work, sir. That details has been mentioned in our paper, sir.
Okay, but interpretation should be needed. Anyhow, okay, thank you.
Okay, sir.
Okay, thank you.
Okay.
Okay, thank you,
So
sir.
anybody more?
We will proceed with our next paper ID. Paper ID 88.
Hello everyone, I am Shankshubra Ghosh. I am now going to present the paper on harmonics monitoring for winding fault diagnosis of brushless DC motors, which has been authored by myself along with Dr. Surijit Chattopadhyay and Dr. Aurobindo Das. The paper ID is 88. On behalf of all the authors, I would like to thank the organizer, the track chair and session chair of MFIIS 2020 to provide me with an opportunity to present the paper. The abstract of the paper is as follows. This paper deals with the very small stator interturn fault in BLDC motor. Here, the effect of stator interturn fault on the parameters like DC component, fundamental component, TSD and subharmonic components of stator current have been analyzed. For different percentage of stator interturn fault, the variation in these parameters have been studied. Out of these parameters, few specific parameters suitable for the fault diagnosis of very small stator interturn short circuit fault have been selected. Then an algorithm has been proposed and also validated using the experimental data collected from 3 BLDC motors of different ratings and suffering from very small different percentage of stator interturn short circuit fault. Harmonic monitoring based parametric selection and comparative study have shown that the subharmonic component current at 12 Hz gives the most satisfactory result for fault diagnosis. Now let us discuss the fault modeling. Figure 1 shows the schematic diagram of fault modeling in BLDC motor. Here the stator interturn fault has been introduced by changing the inductance value of the BLDC motor model. The stator phase A current has been extracted for normal and faulty values of stator interturn fault by the data acquisition system. Thereafter, an analysis has been done on the various parameters for finding out the effect of very small stator interturn fault. The simulation of the BLDC motor model has been done in MATLAB Simulink. Also, experiments on real 3 BLDC motors were carried out in the laboratory for the comparative study and the validation. Let us discuss the effect of interturn fault of stator on DC component. From 0% to 1% values of stator interturn fault, the values of DC component of stator have been monitored, which have been shown in figure 2. But from the figure 2 it can be seen no exact solution can be made that how exactly DC component current behaves with the variation in percentage stator interturn fault. Effect of interturn fault of stator on fundamental component. Similarly, for different percentage values ranging from 0% to 1% of stator interturn fault, the values of fundamental component have been measured for monitoring and the same has been shown in figure 3. From the figure 3, it can be observed that this analysis will not be helpful for the detection of very small stator interturn fault as the value of fundamental component goes on increasing and decreasing simultaneously with increment in percentage of stator interturn fault. Now, the effect of interturn fault of stator on TSD. Here, analysis has been done to see the effect of different percentage of stator interturn fault on TSD values. It has been observed from figure 4 that with the increment in percentage of stator interturn fault, the TSD value also increases. Now let us discuss the effect of interturn fault of stator on subharmonics. Subharmonic component introduce losses in BLDC motor for which motor efficiency decreases. In this section, the various subharmonic components of stator current which are less than 50 Hz have been monitored for different percentage of stator interturn fault and it is shown in figure 5. It is very clear that out of all subharmonic components studied here, only the 12 Hz subharmonic component of stator current is increasing without intermediate drop as the percentage of stator interturn fault has been increased from 0% to 1%. The nature of variation of 12 Hz frequency subharmonic component of stator phase A current has been shown in figure 6. Parametric selection. From the figure 4, it can be observed that when the percentage of stator interturn fault has been varied from 0% to 1%, the TSD value also increases with the increase of percentage stator interturn fault. So this analysis may be helpful to detect very small stator interturn fault in a BLDC motor. It has been further observed in figure 5 that except the 12 Hz frequency subharmonic component of stator phase A current, all the other subharmonic component current at different frequencies were not varying in any particular manner. Figure 6 clearly indicates that for very small value of stator interturn fault, the 12 Hz frequency subharmonic component of stator phase A current increases as the percentage of stator interturn fault has been increased from 0% to 1%. So this analysis may be used to detect very small stator interturn fault in a BLDC motor. An algorithm has been proposed for the detection of very small stator interturn fault in a BLDC motor. First of all, we need to capture the phase current signal from the stator of BLDC motor through the data acquisition system. Then we need to determine TSD and pre-learning based specific subharmonic component of stator current. Then we need to compare these values with normal condition to find out if there is very small interturn short circuit fault. Validation and comparative study. Here the data have been obtained from the experiments done on real 3 BLDC motors of known ratings and known percentage of stator interturn fault. The first motor has RPM of 3000 and second and third motor has the RPM of 4000 and 3000 respectively. The known percentage value of stator interturn fault for the first motor is 0.33% and that of second and third motor is 0.57% and 0.86%. Data obtained from the 3 BLDC motors for 3 cases were further used for the comparative study and validation. Table 2 shows the comparative studies done between the experimental results obtained from the real 3 motors of known percentage of small stator interturn fault at 3 different load conditions. That is at no load, at 50% of the rated load and at full rated load of the motors. Here the percentage error has been calculated to find out which technique is more suitable for the reliable detection of very small stator interturn fault in BLDC motor. The percentage error has been calculated by using the following formula, where error is equals to within bracket capital F minus small f divided by capital F bracket close into 100%, where capital F is the known percentage value of stator interturn fault and small f is the percentage of fault obtained using TSD and 12 Hz frequency subharmonic component of stator current. The percentage error comparison has been done between the data obtained from this experiment done on real 3 BLDC motors of different specifications but suffering with very small percentage value of stator interturn fault which are of known values, and the result of percentage error comparison has been shown in figure 7, which shows that the proposed technique may be useful for such fault diagnosis of BLDC motor of different rating with different set values. Specific outcome and conclusion. From the observation, it was clear that the DC component and the fundamental component of stator current do not give any clear outcome for the different values of stator interturn fault. Only the TSD and the subharmonic current at 12 Hz give acceptable results for the detection of very small stator interturn fault of BLDC motor. TSD and subharmonic current at 12 Hz have increased as stator interturn fault has been varied from 0% to 1%. From the comparative study and the validation done in the table 2, it has been observed that the percentage of stator interturn fault have value obtained only using subharmonic current at 12 Hz gives the most satisfactory result. By continuous monitoring, measurements and comparisons of this parameter, it may be possible to detect small stator interturn fault in a BLDC motor of any rating. For different cases, the frequency component may be different depending on the design parameters. So for different cases, pre-learning is necessary prior to application of the proposed algorithm. Future scope. We believe that this paper has wide scope for future extension, particularly in grid connected system. For fault detection, other statistical parameters of subharmonics, integer harmonics and interharmonics may be analyzed. This fault detection technique can be applied for other types of faults also. This fault detection method can also be applied to other electrical machines connected with hybrid microgrid systems. Especially this technique can be extended for fault monitoring in the induction generator in wind connected microgrid. Also this technique can be applied to solar microgrid connected BLDC driven pumping system. Thank you for listening to my presentation.
Hello.
Hello. Hello.
Yes.
Please ask question. Any listener, please ask question. Hello. Hello.
Okay, Shankar.
Hello, sir. Hello, sir.
Okay.
Did you recognize me, sir?
Yeah. You talk me later on, no problem. Huh?
Yes, sir. Okay, sir. Thanks.
Okay, so you done practical work also?
Yes, sir. Right, sir. Yes, sir.
Okay, so whether this this technique can be applied for like a synchronous motor?
Yes, sir. Synchronous motor because permanent magnet synchronous motor has very much similarity with the BLDC actually. in there is a little difference in between them actually. So we can apply this technique to the synchronous motor as well.
Okay, so as usual, what technique generally used for interturn protection? You know.
Sorry, sir.
Generally, conventionally, which technique is used for interturn fault protection?
Hello.
You getting me?
Hello.
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 Okay.
Oh,
No
sir.
problem.
Hello.
Later also we can talk. Huh? Sir, either we can
Hello,
ask
sir.
for next presentation.
Am I audible, sir?
Yeah.
Yes, sir. You were asking something.
Okay, so you are telling this work can be extended for other motor also, right?
Yes, sir. Yes,
Other
sir.
type.
Yes.
Okay. Thank
Yes,
you.
sir. Okay, sir. Thank you. Thank you.
Doctor, can we proceed with the next paper ID? Can we proceed with the next paper ID?
Yes. Please proceed.
So the next paper ID is paper ID 90.
Paper ID 90. Yes, proceed.
Good morning to all respected session chairs and my dear audiences. Myself, Mr. Shubhodhu Bhattacharya from MCKVIE, presenting the paper entitled Application of Milliman's Theorem for the Unsymmetrical Fault Diagnosis of the Six-Phase Electric Network. My co-author is Mr. Sudip Samanto, Assistant Professor of EE Department, MCKVIE. This is the abstract of my paper. Here we are applying Milliman's theorem for the analysis of six-phase electric network during different unsymmetrical fault conditions like line-to-line and ground fault. In this present contribution, unsymmetrical fault analysis by using exciting well-known unsymmetrical component method is avoided and is applied simple Milliman's theorem to reduce the complexity of the fault analysis. To validate this fault diagnosis system, a MATLAB or Simulink-based six-phase network is developed, and for different fault condition and simulated result is compared with the calculated result from Milliman's theorem. After comparison, it is obviously stated that the fault level calculation with Milliman's theorem-based approach have a great accuracy. The six-phase system has more advantages than an exciting three-phase system, like power delivery capacity in six-phase system is increased by 1.732 times along with the reduction of audio noise, overhead line space and corona loss, which leads to reduce the overall cost. As six-phase network connection is complicated than the three-phase system, so more precise fault detection is the prime issue to avoid the unwanted shutdown of the system. Fault detection by symmetrical component analysis is based on the hypothetical positive, negative and the zero sequence component flowing in sequence network derived from the circuit under analysis. Here, the degree of the complexity is such that the person who is not doing this work regularly, then a fair amount of revision is required when operating with the unbalanced fault condition. So here an alternative approach using Milliman's theorem is developed and only a few number of voltage equations are derived for the various fault and the circuit calculation is solved with the probably no more assistance than a simple handheld calculator. According to the Milliman's theorem, a number of voltage sources V1, V2, V3 up to Vn are in parallel having internal impedances Z1, Z2, Z3 up to Zn respectively can be replaced by a single equivalent voltage source V in series with an equivalent impedance Z as shown in figure. Now I am explaining how the Milliman's theorem is applying in a six-phase network. A balanced six-phase system can be considered with the two balanced three-phase system as shown in figure. If VA, VB, VC and VX, VY, VZ are two balanced three-phase systems, then its corresponding six-phase system is represented as VA, VZ, VB, VX, VC, VY, and each phases are differing 60 degrees from each other. The system equation of a six-phase system will be V phase minus Vn is equal to Z phase into I phase. The values of V phase, Vn, I phase and Z phase are given in slides. And finally, I phase is equal to Z phase inverse into in bracket V phase minus Vn. According to the Kirchhoff's current law, Ia plus Iz plus Ib plus Ix plus Ic plus Iy is equal to 0. So the equation can be written using the unity matrix U into I phase is equal to 0. By putting this value in the voltage equation, finally we get the value of Vn. Here we can see that. In the figure, we can see a line-to-line fault occurs in phase B and phase Y with the fault impedance ZF. The terminal condition for the phase current is Ia is equal to Iz is equal to Ix is equal to Ic is equal to 0. By applying the boundary condition for the fault, we get the voltage matrix. This finally converted into the current matrix. Now, Milliman's theorem is applied to get the potential at the fault point. So we can get the Vf. As for the transposed line, y1 is equal to y22 and y21 is equal to y12 and Vy is equal to minus Vb, then we can say Vf is equal to 0. So the fault currents can be calculated as Vb and Vy. Here we are considering a double line to ground fault in phase B and phase Y with the fault impedance ZF. The terminal condition for the phase currents is Ia is equal to Ib is equal to Ix is equal to Iy is equal to 0. Now by applying the boundary condition for the fault, we get the voltage matrix. As it is a ground fault, Vf is equal to 0, so we get the current matrix. Then the fault currents are Iz and Ic. And Ic is equal to minus Iz is equal to minus Vz whole by Zs minus Zm plus Zf. To validate the proposed fault diagnosis method, a Simulink-based model of six-phase network is developed in MATLAB. Different faults have created externally, and for every fault condition, fault current data measured for the two different values of network parameters. In the first case, six-phase network is supplied by 100 kVA 240 volt 50 Hz six-phase alternator, and in second case the six-phase line is connected with the 138 kV 600 MVA 50 Hz alternator. Line impedance is taken 0.1408 plus J 0.644 ohms per kilometer, and the mutual impedance is taken 0.1821 plus J into 0.2824 ohms per kilometer for the both cases. In this slide, the calculated output for the line fault in different phases is given, and it is compared with the MATLAB output, and it is calculated for the first case. Here, the output is shown for same in the second case. Right, the output is given for the line to ground faults for the case 1. And finally here, the output is given for the case 2. As I told earlier, the calculated output is compared with the MATLAB generated output, and the error is compared with the reference to the MATLAB output. And from the table, it can be obviously stated that the calculated result is very much closer with the simulated result. Finally, I am concluding my paper by saying that this work is basically the application of Milliman's theorem in an unbalanced six-phase system. This Milliman's theorem-based approach is, however, conceptually very much simpler to apply for the fault diagnosis method, as it does not use the fictitious subfrequencies components and network employed by the symmetrical component techniques. In this paper, grounded as well as the ungrounded fault are resolved by using the Milliman's theorem. From the obtained result, it is clear that the calculated results are found in agreement with the measured result from the MATLAB. Here are some references which I used for this paper. Thank you to you all.
Yeah. Thank you for your presentation. So, for anyone to ask question? If anyone want to ask question?
Please ask some question. Please ask some question.
Hello.
Okay, Samanta.
Hello. Can I ask one question?
Yes, sir. Sir, ask.
Can I ask one question?
Yes, sir.
How can you extend this application of Millman's theorem to transient analysis of the fault which may occur?
Yes, sir. This will extend, but in that paper we don't
Here
do
you
that,
are not
sir.
given, but is there any possibility that you can extend it for the transient analysis occurring?
Yes, sir. We can do that, sir. We can use that method for the transient analysis for switching conditions, sir. But in that paper, we just use it for the fault current analysis, sir, and compared it with the MATLAB simulation-based output, sir.
I see. So MATLAB has used some other formula besides Millman theorem or the same thing?
Sir, actually, besides Millman theorem, there are symmetrical component method. But in that case, we have to calculate the positive, negative, and zero sequence
Nah, but
components also. That is
in
very
your
complex
MATLAB
method, sir.
analysis with which you have compared, in your MATLAB analysis with which you have compared, what are the methods MATLAB has utilized?
In MATLAB, sir, we have simulation blocks. From there, we measure the fault current, sir.
I see. So you are sure that they are not using the same method?
No, sir, no.
I see. Okay. Thank you.
Thank you, sir.
Is there any grid application? Is there any grid application of your work?
Yes, sir. We can also apply, sir. That is a very simple mathematical application process, sir. There is no complexity, and it is also applicable for all the transmission and also distribution end. And also we can calculate for the receiving and sending.
Already we have some fault diagnosis techniques. So what are the advantages over existing techniques?
Simple mathematical calculations, sir. No complexity, sir. Here, just
By
using
voltage
Millman's
measurement
theorem.
current. No,
We can also
normally
measure the face-to-face faults by
we
the fault
have
current.
our relay system. We have our relay systems, voltage measurement based, current based, or impedance based. Already we have fault diagnosis methods, existing methods. So what are the additional advantages you are offering?
Sir, actually, six-phase system. Here we are analyzing six-phase system, sir. Six-phase
But
system
normal
is
our power systems is three-phase.
actually it is
Normally
also
in grid system means three-phase systems.
yes, sir. But here we just want to show that it is so simple that we can use it for the six-phase system, sir. Also.
So only simplicity is the parameter, or other things should be considered.
Sir, easily can be solved, sir. Our calculations, accuracy.
So only simplicity.
And sir, accurate, sir. Our process is so much accurate, sir. From our error
Have you
table
compared
analysis.
with other? Have you
Yes, sir.
with other methods?
We will compare that our result with the symmetrical fault analysis techniques also, sir.
No, same fault with other methods.
Yes, sir. By the symmetrical fault analysis method, symmetrical component methods.
Okay, thank you.
Okay, sir. Thank you.
Hello. Hello.
Hello.
Hello. I am having one question regarding six-phase alternator. Can I ask?
Yes, ma'am. You can ask.
Sir, is there practical application of six-phase alternator in our daily?
Actually, we are showing that it is so much easier that we can solve the six-phase system also by using that process. And
So
accuracy is one point also.
So is there any limitation to this use, or there is no limitation to the use of six-phase alternator?
Yes, there is actually that is not covered by my topic. Okay, my topic is on the Millman's theorem's use in calculating the fault analysis, not on the six-phase system.
Yes, but is your work practicable? Means practical applicability is there?
Actually, six-phase alternator is used to fix the six-phase system. Okay.
Actually, madam wants to know, Shubhadeep,
Yes,
you
sir.
have made an analysis for six-phase system. Whether
Yes,
this
sir.
analysis may be applied to any practical system or not. I think
Yes,
that
sir.
is
It is also applicable for the practical system. Also, practically applicable. Sir.
that madam wants to know
Okay, sorry, sir.
whether there is any six-phase alternator is there, or what you are contemplating of the six-phase system.
No, sir. It is also practically applicable.
Okay. Thank you.
Thank you.
So
May I
can
leave?
we proceed?
Sir. Yes, sir.
Yes, yes, leave, please.
Okay, okay. Thank you.
Okay.
So today we now proceed with the last paper ID, which is 95.
Okay, please proceed.
Thank you.
Hello everyone. I'm glad to represent my paper entitled Crisscross Optimization Based Short-Term Conventional Generation Scheduling Incorporating Renewable Energy in front of such a learned audience. Integration of renewable energy sources into conventional generation scheduling by considering economic and several environmental factors constitutes a multi-objective nonlinear optimization problem, including several equality and inequality constraints. Main objective regarding generation scheduling is encountered in attaining least emission of pollutants at a reduced cost for short-term period, maintaining the system constraints. This study proposes a methodology of the short-term hydrothermal wind generation scheduling problem based on crisscross optimization algorithm. The simulation results indicated that the proposed algorithm provides a better solution in terms of economy at a reduced emission than provided by existing heuristic methods, including various complex constraints of the scheduling problem. In present scenario, global warming has become a matter of great concern, mainly caused due to ever-increasing pollution from fossil fuel waste energy extraction techniques throughout the globe. Besides, most of the existing energy extraction techniques are highly dependent on fossil fuel waste resources, which are finite by nature. On the other hand, renewable resources have drawbacks of low energy density as well as less reliability from inherent nature. So the optimal generation scheduling in thermal renewable energy system is a necessity in maintaining economic development in an environment friendly way. The inclusion of wind energy into the energy sector have become more cost effective, thereby making it advantageous, particularly in the scheduling aspect. Main objective of the research was to minimize the fuel cost of the multi-objective function by considering various complex constraints. Results showed that the proposed algorithm can be successfully implemented to provide lower fuel cost at a reduced emission than provided by any other well-established existing methods. It was also evident that a better performance was achieved in view of convergence properties and distribution diversity for solving short-term hydrothermal wind generation scheduling problem. So it can be treated as a promising alternative to tackle this scheduling problem. Formulation of multi-objective function involves the necessary mathematical modeling involved in a thermal power plant, a hydel power plant, and a wind power plant. It is evident that the cost involved in a hydroelectric plant is independent of the output. The total generation cost for hydrothermal wind scheduling comprises the coal price in thermal plants and cost involved in wind and solar-based power extraction methodologies. In such a situation, the objective function should be minimized which comprises the total cost of generation involved in thermal wind power plants during the emission, satisfying all the system constraints. A nonlinear multi-objective function can mathematically be formulated as this one. It represents that the objective function depends on fuel cost, the emission cost, as well as the cost involved in a wind generation technique. This cost expression can be detailed expressed in this way, where this part and this part represents respectively the quadratic cost function in a thermal power plant, this one, and this part represents the emission cost involved in a thermal power plant. These are the costs involved in a wind generation system. Obviously, it can be seen that there are three parts. The first part comprises of a direct cost involvement, whereas due to the uncertainty of wind generation, there might be some overestimation or underestimation, and this second and third term in this scenario taking care of that fact. The fuel cost in a thermal power plant is as evident, it is a quadratic function, whereas if the last term includes the bulb point effect. The last equation involves the constraint that is encountered in power system power balance. It is evident that the constraints related to short-term hydrothermal wind generation scheduling are mainly operating limits of the concerned generator limits, volume of storage reservoir, discharge limits, constraints involved in water balance criteria, and power balance constraints, which is indicated by the last equation in this particular slide. The crisscross optimization algorithm is one of the popular and population-based heuristic algorithm, which is very efficient in solving high dimensional non-convex optimization problems. The main key feature of this algorithm lies in that there are two interacting crossover operators. One is horizontal crossover and the other one is a vertical crossover, and then there will be a comparison between them two, and depending on the survival of the fittest rule, the best value will be selected as the new offspring, which may update the parent value if required. These following steps ensures the existence of solution having better fitness values. As a result, the acceleration factor is for personnel based individuals is greater towards convergence. The steps involved in this algorithm are explained by these four processes. Step 1 is initializing the population. Here the CSO firstly creates a population consisting of D decision variables. Step 2 executes horizontal crossover with its competitor, whereas step 3 performs vertical crossover with the competitive operator. Step 4 is basically the stopping criteria. The process is terminated when total iteration count becomes greater than the pre-specified set value. Otherwise, the step 2 is repeated again to initiate another set of iteration. Moderation solutions initiated by vertical crossover face a competition with corresponding parental solutions stemming from horizontal crossover. Solutions having better fitness values survives in the new generation. Simulation test result. The study intended to address a maximum penalty factor approach to adopt a reasonable solution by combining both fuel cost as well as the cost involved in emission. For this particular study, the proposed test bed includes three things as obvious. First one is hydel power generation, next is thermal power generation, and wind power generation. In the proposed test bed, there were 4 hydel units 3 thermal units and 2 wind energy conversion units, as evident from the schematic on this slide. The next slide describes it is a schematic representation of the hydel plant's water discharge curve for the particular test bed. This table represents the hourly reservoir storage volume obtained using the CSO algorithm over the test bed system. The table on the left side represents optimal generation schedule of the hydro system obtained using CSO method, and the table on the right represents the optimal generation schedule of the thermal wind system using the CSO method. This simulation was carried out in MATLAB environment. The program was repeated for 50 iterations on the test case, and the results were analyzed based on the best, average and worst case with standard deviation. And from the results, it is evident that CSO is very effective and competent in terms of solution quality as well as consistency. This table represents fuel cost, rate and wind generation cost of the optimal ST-HT-WGS problem using CSO. The optimal load allocation between hydro, thermal and wind of the test bed over a 24-hour interval is shown in this figure. And the diagram on the right side represents the convergence characteristics of CSO with comparison to modified PSO, conventional PSO and GA algorithm, and obviously it is evident that it consumes less time if we use the CSO. Whereas the table on the left side represents a statistical analysis of the heuristic algorithm in terms of total fuel cost. For concluding, it is established that this paper explored the capability of few empirical algorithms belonging to different empirical groups to search for the optimal generation scheduling for a ST-HT-WGS system considering various economic and ecological factors. Criss-cross optimization method was adopted in this study for the above mentioned purpose. The concept of maximum penalty factor approach was used in this investigation to transform the multi-objective economic and emission function into a single objective one. Simulation results verified that CSO yielded a better performance than the other selected algorithms from quality of solution and consistency point of view. This method was easy to implement and consumes lesser time to execute an iteration. As a result, the proposed algorithm found its suitability, particularly in case of large-sized hydrothermal wind optimal scheduling scenario. These are the references. Thank you.
Anybody has got any questions?
Oh, is there any specific grid application of your work?
Sir, basically we have gone for this time being, we have gone for standalone systems because renewable scheduling of renewable resources, that was our main motto. But in future, as per your kind advice, we may try it. Sir.
So within few months, is it possible to extend?
Sir, we will try definitely.
What? Within few months, is it possible to extend our to do something for grid application?
Sir, we will try, and we can hope that we will do it.
Hello.
Yes,
Hello.
Yes, sir.
May I ask one question? Hello.
Yes, sir.
Regarding the generation schedule, okay?
Yes, sir.
So have you considered any weather uncertainty or something else?
Yes, sir. In case of wind, the overestimation and underestimation, because wind flow is not uniform throughout the time. In fact, there is seasonal variations too. So there is overestimation and underestimation that has been considered.
So where from you will get those estimations? That is
So
another
there,
issue.
yes, sir. In the presentation there was a prescribed formula from some of the earlier works. They have considered the cost of wind due to fixed cost and includes the penalty factor, which includes the overestimated value as well as the underestimated value. So in this presentation, there was shown the cost involved in wind scenario. There were three parts. First, involve the fixed cost. Second, used
No, have
for
they? Okay, okay, I understand. Have they utilized any estimation techniques or something else?
So
Wind
please repeat.
estimation techniques, whether tomorrow, suppose tomorrow there will be so much of wind during this duration or this duration, that there will be three types of estimation: short period estimation, medium period of estimation, long term of estimations. So what kind of estimations they have talked about?
Or is there any forecasting?
Yeah.
Sir,
Have you got that?
basically it was a short-term based analysis.
Short-term analysis. So your systems will not be operated for a long estimation periods. Okay, you cannot forecast that maybe 4 or 5 days. This may be a generation schedule. This may be a generation
So
schedule
that
like
can be implemented. That can be implemented.
okay. Okay. Okay.
Okay. Thank you, everyone.
Sir, I have question. I have a question.
Okay, okay, okay.
So, first of all, how many constants are considered here for economic allocation, optimization?
Basically, there was for each and individual operating schedule. I mean to say, each and individual plant, the cost involved they were considered. Like for what I mean to
So
say,
one is the
height.
cost. So one is the cost. Next, I mean, how many total constants you have considered here?
Sir, for Heidel, mainly we have considered two constraints like fuel emission and cost involved in wind.
Okay. So, and another thing is that we know that in case of there are two types of long range and short range hydrothermal schedulings are there. So, in case of hydrothermal scheduling, I am telling about. So, in case of short term hydrothermal scheduling, it can be divided I mean, it can be divided in a sub interval. Okay. In case of short term hydrothermal scheduling, is basically 1 day or 1 week, and again it can be divided in sub intervals. So, I want to know what is the scheduling duration you have taken for this purpose? I mean time, because you have to find out the economic allocation of operation for a particular duration of a time. Okay, so that's why I'm telling you that in case of short term, if you consider the hydrothermal only, in case of short term hydrothermal scheduling, generally it can vary from 1 day to 1 week, and again it can be divided into sub intervals. So just I want to know that what is the scheduling interval you have taken for this purpose?
Sir, 24 hours.
1 day. That means 1 day. So total 1 day or subdivided?
Throughout the day. I say total 1 day.
Throughout the day you have taken. Okay. And another thing is that the conventional technique to find out the economic allocation is that based on Lagrange equation and Kuhn-Tucker's algorithm. Okay, which was presented probably in 1951. So I want to know that this algorithm can be used here to find out the economic allocation.
Yes, sir. That can be.
It can be done, na?
Yes, sir.
Okay, okay. Thank you. Thank you.
Thank you, everyone. we close our session, sir.
So, yeah. So anybody has got any questions?
Chairman, please ask
Yeah.
chairman
From
of
my
the
side, no problem. Yeah, it can be closed.
Okay.
Thank you, doctor. Thank you, everybody, for your spending your lovely time with us. So tomorrow again we'll be joining tomorrow morning. Hall 1 starts at morning 10 o'clock and Hall 2 starts at 12:15
Okay.
noon.
Thank you. Thank you, everyone.